Hello, everyone. Welcome to the WorldShop International FTC Conference presented by Team 14278ZO from Romania, 11056 the Ybot from Israel, 7486 Suffern Robotics from New York, 9794 Wizards.exe from the East Coast, 12528 NextGen from Minnesota, 12808 Revamped Robotics from Oregon, and 7593 the Tigerbots from California. My name is Shrey Goyle, and I'm from Team 12808 Revamped Robotics, and I'll be your stream moderator for today. The conference will host teams from around the US, Israel, and Romania in segments of presentation on technical and non-technical topics. I hope everyone will have learned something at the end. After the presentations, we will have team contact information displayed for personalized question and answer sessions. Now let's transition into the first presentation by 14278ZO on team problem solving. Okay, let's hand it over to them.
Hi, my name is Daria,
And my name is Catalin.
and we're from Team 14278XO. We are the first robotics team enlisted here in Romania, and these 4 years of activity have been quite rough for us. My colleague Catalin here can talk better about the past years, so I'm gonna give the word to him.
So we might have had some problems the last 3 years, but we try to solve them one by one, and actually we managed to do that just by collaborating and being motivated and energetic, because these are the main 2 points of a team. If you can't collaborate and if you can't be motivated by the ones around you, you won't be able to solve any kind of problem, no matter how small it may seem or how unimportant.
This is my first year here in XO, and it was something new for me. I faced problems that I didn't face on a daily basis, and it was something that I had to learn to deal with. The first ones were about the non-technical part of the sim, since that's what I do. We've managed to collaborate though and to solve them successfully. It was quite a rough road, so I had to learn new things and how to collaborate with my teammates. Since I was an individual before, I didn't know how to work inside a team and how to work with new people. I had to learn to do that, and because of that, we learned a new problem solving method that really helped us through. The first thing is defining the problem. Is there a problem? What is it? How significant is it? It is something that we have to learn and to get across, because knowing the problem or knowing how significant is it helps us really much. Analyzing the problem would be next. Why is it happening? We have to know why the problem is happening. We have to get to the bottom of it, because it's very crucial to know the base of the problem. Next, determining what to do. What shall we do about it? We have to get some points. We have to find some answers for the problem, and we work as a team to find these answers and to find things that can help us. Implementing the plan with fidelity would be next, because we have these two main questions. Are you doing what you said you would do, and how do you know? Since we're a lot of there are a lot of people in this team, we have to spread equally the things that we decided we would do to solve the problem. And since this is a very crucial part, we have to know that each person is doing the right thing. And the last step would be evaluating the progress. Did the plan work? What needs to happen next? The most important question under this category is what needs to happen next. We have to set some ground rules and to know what went wrong so that in the future we will not do the certain thing again. Another thing that helped us a lot were the team building activities that we do throughout the year. We like to think that we are not a team anymore. We like to say that we are a family, a huge family of very different members. And during these team building activities helped us a lot. We go out, we like to talk about our personal lives, our lives in this team. And since this is happening, we managed to bond very much, and it helped us even while playing board games or going at someone's house. Small things like this make a huge difference, and they managed to help us solve our problems easier since we know each person's personality, and we know how we managed to obtain a lot of know-how about the different people inside a team. We like to think that the team building activities that took place and will take place are a major thing that went into the problem solving inside this team. Also, we have a few tips and tricks about strengthening the problem solving skills of your team. We like to start with reasons why your team can solve certain problems. First of all, it's micromanaging. Micromanagement is about when someone, a certain person, takes the lead fully and completely. And this isn't quite right since as a team, indeed, you need a leader. But that's why it's called a leader and not a boss, because being a leader means that you coordinate your team, you help your team, you don't just stay on the sides and give orders. That's why we like to speak with each other, to talk with each other, to have as many meetings as we are supposed to have. We like to, even if it's something really small and insignificant, we take it as a significant thing to discuss, and we debate it until we can know more. So that's why we consider it an important thing to take, in fact, each person's little opinion and get every opinion together and make something good out of it. The next thing on the list would be no mistakes allowed. This is a subject that's a little bit more delicate because we are high schoolers, we are young, we don't have yet the knowledge to be superior, to manage to work perfect in a team. We are still learning, so this thing with no mistakes allowed really bugs us. Mistakes should be allowed because when you do a mistake, you learn from it and you learn how not to do certain things. So this thing with no mistakes allowed, we like to keep it out of the business because we like to make mistakes. We truly like to make mistakes sometimes, and even though sometimes we're angry and we're mad, we're sad that we didn't do things properly, we truly learn from it. Another thing would be no team development, and because I talked about team building previously, team development is very crucial because if you don't know who you're working with or what you're working with, you can't collaborate, and that means that you can get a group of people together and make them work for the better.
So a thing that we like to do to encourage the new members to come up with their problems and tell us actually what scares them or what makes them feel uncomfortable in the team is to actually transform every single little problem into a small victory. Because when you come up with something that you don't know, that maybe annoys you and which might even make you feel that you are not wanted there and that you actually can't find your place in a team, no. If you want to do that and if you are sure that that's the right place to be, you have to tell somebody, and you have to make them realize that solving every little problem makes the entire team grow stronger together and transforms every moment like that into a small victory. All these small victories will actually sum up in a very nice season that you will be very proud to remember, because that's what you want to do. By in first, you want to solve problems, to have a great time, and to feel good in a team.
We were very scared at first to tell them our problems, to tell the veterans of our team the problems that we come across. So having them so open-minded and so there for us meant a lot for us, and it still means a lot to us. At first we were a little bit shy. We didn't know how to properly tell our problems, to be confident enough to tell them our problems, but it is very important to have a team that is really open-minded. And when, for example, you have a team that changes every year, new people come across, the team members change, it is very important to have people there that can guide our new teammates during these years and that can properly make them feel comfortable and to help them improve the experience that is the first SEC challenge.
Another thing that you want to do is to set the bar high. That means to constantly set yourself and the team goals, so that you have to aim higher and higher every time you try to do something new, or even make an upgrade to the robot, or try to simply become a better team by improving your team chemistry. The most important thing about setting a high goal is to actually set a possible goal. Because if you can't achieve that goal, your team will become more and more frustrated, and you don't want to get to that point. Because what's the most important thing in a team is to actually, as I said earlier, be happy when you're there. Because setting your goals may be a thing, but achieving them is giving you a feeling of not only joy and hope, is also a feeling that yes, you belong there and that you are good at that. And I think that that's the most important feeling that you can get in a robotics team, that you belong in a group of people, that you help them and that they help you, and that you become a family just by setting big goals or small goals to achieve something bigger.
Another thing on the list would be watch how you respond. We know we all get frustrated, we all get angry, we're sometimes tired, we feel like we can't do certain things anymore, but it's very important to stay calm, be there, be present both physically and mentally, to be able to be kind. You know how first values gracious professionalism. We like to be gracious also when we are outside of the competition, when we are here working at a lab or doing some activities outside, or when we meet at a team building, because it's very important to have that information imprinted, that you have to respond with kindness, to be joyful. When you have to tell someone something that didn't work out quite properly or something that they have to do, it's better to use a nicer voice, to stay calm, to get your point across like this, because when you're angry, reason doesn't come to you anymore. And working with this thing with gracious professionalism when we're talking about problem solving has helped us a lot. So as you may know, we've experienced a lot of problems, both non-technical and technical. My teammate Catalina will talk about the technical problems.
So, on the technical part, you always find a problem. It's almost imminent to bump into something that you didn't think of properly, or that you actually didn't even think that could be possible to happen.
So when we bump into these problems, we like to get together and talk about every single thing that went wrong. And we like to discuss new ideas that could work for our little robot and that could help us improve its performance. On the non-technical part, we also experienced certain problems. When we talk about sponsorships, there were a lot of troubles going on because it was tough to solve the problems between us when we talk about sponsorships. But we managed to do that by also getting together what we could do to meet more plausible sponsors, and that helped us a lot to get even more know-how and knowledge about how things work. We also experienced a lot of troubles when it comes to the engineering notebook, because it was something that at the beginning we didn't know how to do. It was something new for us, it was something that was out of this world, and we tried to collaborate on this and try to get everything and to get the best out of it. The problems that we faced when it came to the engineering notebook were both on the outreach and on the technical part, the business plan, the sustainability plan, and we had to speak also to people that knew much more about these subjects than us. So also collaborating with people outside of this team, people that have a lot of experience, helped us a lot to solve our problems in this department. When it came to things like writing about our event or writing about what the robot does, it was a little bit easier for us, but certain ideas from one person don't match up with the ideas of another person. So we had to compromise and get our ideas together, and compromise is a big thing for problem solving, because if you don't compromise, you won't be able to get along with your team so easily. When we talk about XEO is a lot of compromise when it comes to problem solving, because we're very different people, we're very different ideas. So getting together a group with so many different ideas was tough in the first place, but now we find it works best for us, and the compromises that we found and that we managed to get across helped us a lot.
So another major thing in solving team problems is actually motivating the team. You won't be able to find the problems, and you won't even be able to get to discuss them if your team isn't motivated, just because they will be like, oh, okay, that's a problem, we can ignore it, or it will solve sometime. But no, actually, motivation is one of the biggest things that you have to take care of. Because if your team isn't motivated, you're just going to fall apart as a team, and people might be finding the team from that moment on not so attractive as it seemed before, and also maybe not that useful. So you can't let that happen, because I think that everyone wants to get along with his teammates and see them happy every day. So motivating them in doing something and in simply collaborating or even talking in the lab, it's something that actually strengthens the team and helps it develop to its best.
A question that is still on my mind is, why is problem solving important in a team? Problem solving is important in a team because it's a part of business, a part of going through difficulties, a part of overcoming challenges, and so on and so forth. But it helps us a lot because the feelings that we have when we are truly involved in a competition of this sort is something so wonderful to us. It's a feelings that we haven't felt before, and because of this, we keep this in mind, and this is a solution for our problems. We always remember how we felt during these competitions, and the fact that the emotions that we developed are such a big part of our lives. It means that we have to move on and to solve every problem that we have, because in comparison, The satisfaction that we earn at the end of the day are two totally different things when it comes to quality. Because when we're talking about this, problems are such a faraway thing.
So, actually, a moment in time that solving problems is very important is before a major competition, like before the regional competition. I'm using this just because ours was 4 weeks ago, and normally before a competition there is a lot of stress and people are just getting tired because the competition is very consuming and because we have to do a lot of things that we wouldn't normally do, like make presentations for the judges, think about how to organize the pit and stuff like that. And all of these things actually just go together and create a big mess in the team that can't be solved without collaboration and without a clear mind. So just try to keep a clear mind when you're trying to solve problems, especially when you're tired or when you feel that you just have so much things to do and you don't have the time to do them, because everything will be all right. All the things will and all the problems will be sorted out, and in the end everything will be fine. The only thing that matters is for you to be sure that you're doing all the things right and to act fresh. Like, don't try to solve a problem at 10 p.m. It won't really have a solution at that moment because you're tired, you're not going to do anything. You should better go to sleep, and the problem can probably wait until the next morning.
Another saying that our team has is motivation firstly comes out of passion. After defeat, it comes out of frustration. And because frustration was a big thing for us at first, it was something that we had to deal with on a daily basis. We found out a few tips and tricks that we tested out a lot and found out that really help us. And one of them is separate ideation from evaluation. And that means when you brainstorm creative ideas, have a separate time to jot it all down. You can focus on generating the ideas first, and after you thought everything out and got ideas from everybody, to prioritize them. Nothing stops the creative flow of ideas like judging, because when you stop to judge a question and when you come with negative ideas, the person that came up with the idea will suddenly feel a little bit more under evaluated. So we have to keep this creative flow going, and when challenges are started, we have to end them as open-ended questions. Also, we have to restate problems as questions. It's better when you restate problems as questions because it's easier to entice a group when you do this thing, and it's easier when challenges come up as questions, as what can we do with it, or what can we do about it, what can we improve, so on and so forth. Another thing that we like to use, I'm sure you've seen an improv comedy class or something of this sort. It's fun to use yes and. When ideas are flowing in the group and you're in a brainstorming session, problems arise, ideas arise, things like that. And when you put an end to it with no or but, it can scare the person talking. So using yes and, it will give the person talking a bit of confidence to go on with the idea. And also when you use yes and, you can improve the idea with your own opinion. Also, there are a few questions that come into problem solving. For example, ask what is going on. You have to be informed of the problem. You have to know what's happening, what caused it. It's best to define the problem. And this question, what is going on, is something that is filled with empathy. Another question is ask, what is success? How can we manage to be successful? How can we manage to finish a project? How can we do that? How can we do that? And all of these things are under one category. What is success? And because many problems arise when we are talking about success, and I think we know this the best, success comes with a lot of problems. So that's why it is important to prioritize our questions, to know the base of the problem, to know how we can manage to solve it. And solutions come up when we ask ourselves, how can we do it? How can we settle it? Because after all, a problem is a quarrel, is sometimes turns into a little fight that we have to evaluate. And after evaluation, we forge a solution. Another thing that we didn't really talk about is really a problem there, because sometimes we like to overcomplicate our lives, and there really aren't out there as many problems as we think. We have to relax sometimes a bit, and we have to think, will this problem matter in 5 days, in 5 weeks, in 5 years? Sometimes, yes, it does matter in 5 days, but in 5 weeks, the problem is gone. So we have to calculate a little bit. We have to stop making mountains out of molehills, or to be so stressed, because when stress and overexhaustion comes in, yes, every single thing will be a problem for us. Another thing would be, okay, accept the problem. We know that it's a problem. We like to go around it. We like to say that we solve it with fun ways or to get it out of our minds. But at the end of the day, we have to accept it. We have to accept it's a problem, even though it's minor or major. Now that you know that the problem just exists, you can put your energy into creative ideas that can help you solve it. Another very, very important thing that we don't like to admit, we don't like to ask for help, but it's important to ask for help. Sometimes our egos don't let us ask for help. We like to say that we are capable of doing all of the things by ourselves, but asking for help won't hurt anyone, and it's very important to solve a problem with people that can help you. And this is why we are a team. To ask for help, to collaborate, to work together. So sometimes it is better to solve the problems with someone that can help you rather than solving them on your own. When you find out that you have a problem, you don't have to use 100% of your time focusing on the fact that the problem is there. You should, 10%, 20%, yes, you can focus, you can think about the problem, but I'd rather say that you can use 80% of your time to focus on solutions and to come up with the best of them. It's important to not complain or whine about the problem. It's better to focus on finding that thing that will help you get through it. As another point, it would be best to break the problem in smaller bits, because when you break the problem down into smaller problems, you get smaller categories. You can focus a lot easier. You can solve the problem much faster, because small parts help you focus only on one thing. When you solve part of the problem, then you can move on to the next. Something important that we've learned through the years is that when you have a problem, try to find the opportunity behind it, the lesson that it gives you. And this isn't quite problem solving, but it is something that will be beneficial for you. It's something that helps you develop personally, both professionally and personally, but more so on a personal level. When you try and evaluate the problem and see what went wrong, you have to learn from it. And when you learn from it, then you can find out what not to do in the future. And that helps you see things that you haven't seen before, that will make your future brighter.
Now, another important thing that you have to be careful at when you're trying to solve a problem is actually the technique of solving a problem. So, there are a lot of ways to approach this, but first you have to look at yourself, because you can't just think, okay, that's my point, I'm going to stay in it, whatever. No, you actually first have to look at yourself and then at the context, because a lot of times we are actually just too lazy to think that, okay, the other person might have a point and what they're saying might be relevant and it might actually be right. So don't try to just focus on what you're saying or what you're thinking. And another important thing is to try and not get angry. This is very important just because when you're angry, your mind just won't work properly. Try to keep calm, try to see the situation from an objective point, and try to look at the problem like it wasn't actually a problem, like it was just something that someone said and that you have to think about. Because it will immediately make all the people in the room feel that there is no tension and that there isn't any mindset of, okay, we have to think of a solution, of an immediate solution to this, or else something bad will happen. So just try to stay positive when you're thinking about a solution and just try to make it as simple as possible.
Another thing to prevent problems is to always check your work. While doing your work, is best to sometimes take a break, take a breather, to not for long, 5, 10, 15 minutes. It depends on how much you've worked. But it's okay to say, okay, I'm going to relax for a minute, I'm going to stop, I'm going to get my mind back together, get it all in one place to be able to continue properly. It's best if after you've worked, to check your work. When you've written something or you've worked on the robot, to stand back and assess the situation. What did I do? Did I do it right? Did I do it wrong? Do I have to change anything? Do I have to improve anything? And while checking your work, you can always solve problems that could appear and new ideas could come to you. It's a win-win situation. It's usually a saying that detectives have. It's something like this. Great detectives always look back and check their work, so check yours too. It's important to always focus also on the details, because details make a difference, and if you ignore the details, again, problems can arise, and when you add up minor problems, it turns into something big that you can't control anymore. So it's best if you work out, if you manage to prevent all of these things and make it work properly.
Another technique that we have to use and we really recommend you to use is to actually start listening to everybody. You can't solve a problem if you don't listen to everybody. If you don't see all the perspectives and all the objectives and also subjectives views, you won't be able to realize how important is for someone on your team to solve the problem, and actually how important is the problem to them. Like, if it really needs to be solved right now, or if it's best to just let it settle a little bit and have time to think. So just start to listen and teach everybody to listen, because it's also a philosophy thing. When you start listening, you actually start knowing a person. You actually get to understand that person, and you actually make that person realize that you care about what they're saying and that you understand their troubles. So listening will just improve the time and actually the personal involvement of how you solve a problem and how the entire team actually feels about that problem and how they feel when the problem is solved and everything is clear.
I know we're talking today about problem solving, but it's also good to talk about preventing problems. And when we're talking about preventing problems, I like to start with explaining the consequences that can appear. And we need to explain them ahead of time, because when you start with consequences and when you make them clear, it can help a lot to prevent the problem, to help the people stay away from the things that could have really, really bad consequences for your team, and to help improve the system that the team has created. Another thing would be to set some rules. Set some rules so that they can be met, they can be followed, and make them clear. Because it's important. I know that we are a team that is open-minded, is playful, is fun, but we also are very serious, and we have to work in a good environment. And for a healthy environment, we need some rules to be able to function properly. Also, you need to provide a schedule and a structure. When you follow a schedule, when you follow a structure, it's easier for you to develop the things that you're doing in the right way, and to help create a healthy working environment that is beneficial for everyone in this team. Another very important thing that we like to avoid is when it comes to impulse. Some of us maybe have a stronger impulse and can be a little bit more harsh in decisions taken, so this can create a lot of problems. When you try to talk about a team, you have to control your emotions, because it's such an important thing to control yourself when it comes to a team that can develop a lot of problems. So controlling yourself and making yourself the best that you can be really helps you move on and avoid the problems that can arise from this. Planning ahead is also a subject that I want to talk about, because sometimes you're overwhelmed, you're stressed out, you're angry. We've talked about this before. It can create you a safety blanket that can make you feel much more comfortable, and having all the points written down or a calendar full of things that you have to do, problems like, I don't know, time management or things that haven't been done quite properly, those problems disappear. You have a clear time of work, you have a clear schedule just by planning ahead. Next, I'm going to be talking about feedback. To prevent problems, you have to ask for feedback. You have to ask about your teammates' opinions. Because when you don't ask about their opinions, they might get sad, they might get upset, and this is a major factor to problem developing. So you're doing a good to yourself, to the team, when you're asking for feedback. It's nothing more than a simple question. How did I do? How does it look? Can I do something else to it? Can I add something else to it? It's as simple as that. A couple of questions that can help you prevent a few problems. Also, another major factor to preventing problems, it's consider hypotheticals. When you consider something that isn't there yet, you prepare yourself for what is coming up next. If I do that, what will be the outcome? Is it good? Is it beneficial for the team? Is it something that won't help us? You have to put these things in a balance. So think something before you do it. Is as simple as that. Also, test thoroughly, because if you test your idea, your hypothesis, it helps you see, does it work well with the team? Does it work well for us? Does it do us any good? It's something small that can help you so much more. And while you test thoroughly, you have to track the progress. When you track your steps, if something goes wrong, you can see that step went wrong, or that one, or the other one. And by tracking your progress and seeing all the steps that you've done and documenting them, you can find out what went wrong, when it went wrong, and you can set it straight. You can avoid creating a much bigger problem when you eliminate the smaller issue.
And actually, another thing that we can't forget is actually how beneficial it is for a team to solve problems. It brings all the members together, it makes them feel happier, it involves them in actually becoming a family and determines them to create something that they will be proud of. This will also motivate them, and overall, solving a problem will just make all the things work better. Not because, yes, you don't have one more problem to think about, but actually because you create something bigger that with every problem solved and with everything that you develop and with the relationship that is also developing in a team by solving problems, you're just going to get better and better simply by creating better relationships with your teammates.
Team devise tasks and multiply success.
Thank you, Team Zio. That was an amazing presentation on team problem solving. Now, if anyone has any questions or comments for Team Zio, please post them in the live chat. You can also contact them offline at any of these channels. Our next topic is going to be on judging and awards, and we will start at the top of the hour. Hello, everyone. Um, we'll be transitioning to the next presentation in 5 minutes, and please continue to post your questions in the live chat. Welcome back, everyone. I hope you all learned and enjoyed from the last presentation by Team 14278 ZEO on team problem solving. Our next topic is judging and awards, presented by Team 11056, the Ybot from Israel. And now I'll transition it over to them.
Hi, my name is Maya, and I'm a team member from Team DYBot 11056 from Israel, and a former team member from Team Ishmash 12016. Today I'm going to talk about judging and awards. Um, I'll start by talking about the judging process in a competition in general, and then I'm going to talk about each and every step individually. Um, and then afterwards, I'm going to discuss about the different awards and the criteria you need in order to be a nominee for each award. Um, I'll also touch a little bit about the engineering notebook. I'm not going to go in depth on that topic. We have a different talk for that, but it is relevant for judging and awards. So we'll talk a little bit about that. In this presentation, I mainly relied on a document that first issued. You can find the document in the games and season materials on the First Inspires website. I'll try to link it in some sort of way. And I also relied on my personal experience in the FTC program. So before we get started, I'd like to apologize if I have any spelling mistakes or if I say some things wrong. English is not my native language, but I'll try and do my best to pass on the information that I want. So let's get started. So let's start by talking about the judging process in a competition. The first step is the judge's interview. As I said later, I'll just go a bit more in depth on each and every individual step. So first is the judge's interview. You have about 10 minutes to talk to a panel of 2 or more judges and tell them about your team. After the judges finish interviewing all the different teams in a competition, they'll do evaluation of performance of each team in the interview and decide what teams they would like to hear more about. After they'll finish, decide that they'll have pit interviews. Different judges would come over to the pit area and come ask questions about the different topics that are relevant for the award that they think your team should be nominated to. And then after they'll finish the pit interviews, they'll go over your engineering notebook. They won't read the entire thing, but they will read the parts that are relevant for the award that you are nominated to. After they'll finish evaluating your engineering notebook and the interviews, and they have all the information they need, they will sit down and process it and reach the final decision about the winner for each award. So let's start by talking about the judges' interview. I'll do my best not to speak about technical things because you can find this information in different first documents and you don't really need me in order to get to this information. You can find almost everything on the First Inspires website on the game materials. So I'll mainly try and give you some tips and things that I've learned over the years. So the judges interview is at least 10 minutes long interview. On the first 5 minutes, you can speak without getting interrupted by the judges, and after you finish talking, the judges will start to ask questions. Technically, you're supposed to have 5 minutes without getting interrupted by the judges, but from my personal experience, if you speak fluently and won't like stop along the way and say things like very short and swiftly and be relevant, they won't stop you. I think 7 to 8 minutes is about the time that the judges would start losing focus on what you're saying. So I think that would be the best time to finish your prepared presentation or what you're prepared and practice on talking about. Another thing is choosing who is coming to the interview. Sometimes you may not have like a variety of people you can choose from. For example, last year in Mishmash, we were 8 team members, so you had like a small amount of people to choose from, but luckily we had many people that could speak. So what I was trying to say is choose who's coming to the interview. I think you need to have people from each and every sub team. Like you need to have someone from programming, you need to have someone from mechanics, you need to have someone from outreach and marketing, just to have people that are experts in what they're doing, that they know everything that happened in that sub team and in that topic. Uh, Obviously, everyone needs to know just the basic of everything, but you don't. You must have someone that knows every single thing on this topic. Like, for example, if I'm from the marketing sub team and the judges would ask me about our robot, of course I would know to answer like basic questions. But if they want to go a bit more in depth on different things and I don't know, want to know a bit more about the code, I'd rather have someone in there that just knows exactly what's going on there because he was involved in the entire process. So there's that, and also do your best to choose people that are enthusiasts and um, knows how to speak well and are spokesmen, because that really does make the difference between, I think, a good judging room to a great judging room. Um, Mainly be authentic. The judges and people in general can recognize when you're not being authentic, and maybe just saying things more than you actually did. You've done a lot of hard work through the season. Just say what you've done and say it like with enthusiasm and be excited about what you've done, because you really put a lot of effort into that, and the judges will see it. Um, and try to talk about all the topics you want. You have 5 to 7 minutes um, to show the judges all of the hard work you've done in the past 4, 5, 6 months. So be very thorough, but try to be concise. Don't go too much in depth on different topics. Those are like the 5 minutes you've got to show them everything. Um, this year, we've decided mainly not to prepare on what we're going to say rather than how we're going to say it. On our preparations for the interview, we mainly just talked with each other about what we want to say. I don't think we had like a preparation and that we've said the same thing each and every time. Like each time it has changed, but we got better in the way we're saying things. We've been more enthusiastic, and we just showed better what we want to say. After the judges will finish interviewing all the teams in the competition, they'll sit down and discuss the teams that were strong in different topics. On that discussion, each one of them would write a list about teams that they want to hear more about. Maybe it's about the robot, maybe it's about the program. You can't really know. So after they'll finish this discussion, some judges would come out to the pit area to do pit interviews. So each judge has some sort of list of teams that they want to come and visit and interview and ask them more about different topics. And about that, I have some tips for your pit area. The first thing is having a well-organized and static pit. The pit area is maybe the only place in the competition where you can show everyone, not just the judges, but also other teams, the way your teams manages and works. For example, this year my team and I decided that our pit area would be only for exhibition and display. Different tools and replacement parts for the robot weren't at the pit area. They were on the mechanics team members or the drive team, and if there were tools in the pit area, they were hidden behind the display things, just so that the pit would always look organized. It's just the best way to show outside that your team is like organized and know what you're doing and you have everything in place. And beside from that, in my opinion, each team should assign a team member as a spokesperson for the pit area. Someone that would be at the pit non-stop, or maybe have like two people that just do shifts and replace each other, but having someone at the pit area all the time. Sometimes the judges would come over to your pit area and they would like to interview about, I don't know, the robot, your outreach work, and maybe if there won't be anyone there, they'll say, okay, I'll come back later, but they're humans and they may forget it, and you've lost the chance to talk to another judge about your work and see and show them what you actually have done for the past 4, 5, 6 months. So that's about your pit area. And then after the judges will finish the pit interview part, they'll sit down and go over the engineering notebook and discuss with each other about the different teams. So as I've said, I'm not going to go in depth about the engineering notebook later. I may talk about some parts that should be included in the engineering notebook for different awards, but again, I'm not going to say like what exactly you need to have in there. We have a different talk for that. One tip or thing that I need is very important for your engineering notebook is having dividers, like a very easy way to reach for different things. The judges are most certainly not going to read the entire engineering notebook. That's like, I don't know, 100 to 300 pages, but they will read the different parts that are relevant for the award that you are nominated for. So having like small dividers would help them get to different places quickly. And also for this year engineering notebook, for our engineering notebook, I added in some sort of places small arrows with like, if you want to hear more about ABC, you should go to page 100 something, I don't know, and just told them that besides from what they're reading here, they should probably go to read somewhere else about more work. Like add within the engineering notebook when they'll come over to one part, maybe just small way to tell them you can go and check out also that because this is also relevant. So now let's start talking about the different awards. Here is a list of the different awards that aren't like optional awards. There is the Inspire Award, Think Award, Connect, Calling Sarah, Space Innovate, Design, Motivate, and Control. Later on, I'm going to talk about each and individual award and what is required in order to be nominated for these awards. So besides from these awards, there are two things that are required in order to be nominated for each of the awards I mentioned earlier. The first one, and you'll see it later on the requirements for every award, is gracious professionalism. First, set that as the first requirement for each and every single award. And the next thing is submitting an engineering notebook, and within the engineering notebook, having relevant parts for each award. So those are two requirements that you must do in order to be nominated to almost every single award. So the first award we're going to talk about is the Think Award. Think Award is pretty much a robot-related award. Again, in order to win this award, you need to submit an engineering notebook and be a gracious professionalism competitor. But within your engineering notebook, you must include different game strategies, how STEM come to life in your robot design, having a detailed, documented, and thorough engineering design process, and showing how throughout the entire season you went through a process with your robot building and design. You also need to add drawings and pictures of the different mechanisms and development of each mechanism. So that's pretty much it. The Think Award is for documenting and showing the process you went through with your robot. And the next award is the Connect Award. This award is not robot related, it's more like outreach related. So the Connect Award is an award for about your community work and outreach work. In order to win the Connect Award, again, gracious professionalism and engineering notebook, but also you must have within the engineering notebook a team plan. Team plan doesn't mean necessarily like a financial plan. Um, you should have financial plan, but also having like your goals and what you want to reach as a team this year, and what you are planning to do in order to get them, how you plan on how your team is planning on being sustainable and continuing throughout the years, and making sure that the knowledge you have and things you're doing are continuing throughout the time. And also for your community and outreach work, exposing first for different communities, and working in different communities and different circles. So the Connect Award again is pretty much like an award for community work and outreach. The next award is the Collins Aerospace Innovate. So this award is again a robot award. In order to win this award, you must have inside your engineering notebook a documentation of your engineering design process and how you've got to this robot design. You must have a well-designed robot that is also unique, a reliable and consistent robot that meets up with your strategy and meets up with your team goals. So that's about the Collins Aerospace Award. And then there's the Design Award, again, another robot award. On that award, you must have sketches of your robot. It could be hand sketched or CAD, 3D designed robot on the computer. The robot must have like shows how industrial designs come to life in that robot, aesthetically, functionality. Like the robot must work well, must look good. So design award is pretty much about how the robot looks and works. The next award is Motivate Award. That award is pretty much given for a team for being an ambassador first. That means that they are spreading the first culture and spreading the first principles everywhere that they're going, and they're showing how each and every team member is taking part in the team and are being active member and important member. The next award is the Control Award. This award is pretty much about the program. In order to win this award, you must file or submit a form beside the engineering notebook. I think you can find the form on First Inspire's website on Game and Season Materials. As much as I know, here in Israel, you can find the document on the First Israel website. So I don't know if this is also like that for different regions, but I'm pretty sure you can find it on the First Inspire's website. Sorry. So in order to win this award or be a nominee for this award, you must include within your engineering notebook different components and you're using on your robot and your code, just to show how you actually control your robot. So you must show the different sensor you're using and in what you're doing in order to use them, how you actually get maximize the way your robot works, and making not just a good built robot mechanically, but also a well-functioning robot while you're using your program. And the next award is the Inspire Award. Why I put this award last, this award is pretty much relied on the other awards that we have talked so far. As you can see in first definition of this award, this team is a top contender for many other judged awards. So this award is pretty much given for a team that is a strong contender for all the other awards. Besides from what we've said before, again, the team must be a gracious competitor. They must submit an engineering notebook, and in the requirements, you'll see that in the engineering notebook, you must include all of the things that were required required for the other awards. So that means having like a part for the code, a part for the robot design, and documenting the process you went through the season. Um, Having a documentation of your team outreach work, having information about your team plan for the season, financial and business plan, just really having all of the things that are required in the engineering notebook. So you really need to have everything in the notebook in order to be a nominee for the Inspire Award. Um, Also, the team must show that they are engaged in the work that they are describing. The team members must know what's going on in the robot, what's going on in their program, what they're doing in outreach. Like really be a strong competitor and just showing that they're engaged in everything they're doing and they know everything that's happening in their team. On the past series, last year I won with Team Mishmash, the second Inspire in Israel, and this year we've won the first Inspire in with the YBot. So, from my experience about the judging process in order to win the Inspire Award, many times you'll have 5 to 6 teams of judges coming over to pit area, and each and every time they'll have like different questions. Maybe 3 times they'll come and ask about your robot, and 2 times about your outreach and community, and then about your program. So that was like my experience for the past 2 years with the judging in the Inspire Award. Um, and I just want to mention that all of the awards are just given by people and humans that have their own opinions. Maybe they have like opinion from before, or maybe you weren't really able to impress them enough during the competition. So that's just something that I wanted to mention. That those are still humans, and you have a very limited and short amount of time to show the judges what you've done. Like 1 or 2 days is merely not enough to show the hard work that your team puts into 5 or 6 months. So that's something that you really should remember. And besides from the awards that we've discussed earlier, there are the optional awards. To be honest, I haven't really got the chance or ever experienced in working on Promoter or Compass Award. So I'm just going to say like technical things about them, but I haven't really got too much into working about them. The Judges Award is an award that each competition organizer can choose whether or not they want to give them or not. So that's like something that may or may not be at your competition. By first, Judges Award is an award that the judges are allowed to give for a team that is just very enthusiastic and really work hard in the competition, but don't really answer for the requirements of the other awards. So then there's the Judges Award. I think this year in Israel, on the Israel Championship, we had 2 different Judges Award. So then there's it. Compass Award is a video file award. So in order to win this award, you have to make a video, 1 minute video, about a mentor or volunteer that you want to cherish and show him how much you appreciate him. This award must be filed, I think, 1 month before the competition. I think it's different from region to another and different competitions. You must check with your local competition organizer. So the Compass Award is pretty much an award to express your gratitude for a mentor or volunteer. And then there's the Promote Award, which is also a 1 minute video award that you need to file before the competition. Again, check with your local competition organizers about when you need to file them. Promote Award is pretty much an award for making sort of advertisement for First. This year topics was how First changed me. Again, I haven't really got the chance to work on these 2 awards, so I can't really like give you some tips about them. So that was pretty much it. That's my team's contact info. If you have any questions, you're more than invited to send me a message through WhatsApp or contact our team through Instagram or email. We would be more than happy to answer if you have any more questions or things you want to know. And that is it. Thank you so much for watching.
Thank you, Team 11056, the Ybot from Israel. And that was a really good presentation with a lot of valuable information on judging and awards and the strategies that you can use to enhance your judging presentation. Now, if anyone has any questions or comments for Team the Ybot, please post them in the live chat. Or you can also contact them offline at any of these channels. Our next topic is going to be on managing documentation, and we will start at the top of the hour. In the meantime, continue posting your questions in the live chat. Hey guys, just a reminder that we will be starting the next presentation in 10 minutes. And in the meantime, please continue to post questions or comments in the chat. Welcome back, everyone. I hope you all took away some useful information, um, and you enjoyed the presentation, and we'll be starting in 5 minutes. Welcome back, everyone. I hope you guys enjoyed that last presentation on judging and awards by Team 11056, the YBot. Our next topic is going to be managing documentation, presented by Team 7486, Suffern Robotics from New York. I'll hand it over to them. Hey guys, sorry about that audio issue we were having. We have resolved it, and we're gonna restart Sufferin's presentation with audio this time. So I'll now hand it over to Sufferin Robotics for their presentation on managing documentation.
Hello, we are Suffering Robotics from Suffering, New York, and we're going to be talking about managing and the importance of documentation. And if you have any questions, you can go on our website or email us at jordan@sufferingrobotics.org. Before we get started, I'm going to tell you about who we are as a team. So we're Suffering Robotics, which is located in Suffering, New York, which is about 45 minutes outside of New York City. And we have been a team for over 13 years, and in the past, 6 years, we've been to the World Championships 5 times, so we're a pretty successful team. Last season, we won the Think Award 3 times, twice during qualifiers, and once during our regional championship, so we're pretty knowledgeable when it comes to documentation. Additionally, last season, we also advanced to the World Championships in Detroit, where we were a finalist in the Connect Award, which again kind of relates to documentation via the business notebook. And we participated in WorldShop last year, and we are so thrilled to be a part of it again this year. And we want to thank you all for watching and being a part of this with us. Documentation is an extremely important aspect of robotics, and there are many different reasons to focus on it. One of those reasons is for awards. A solid notebook is required for all judged awards. A good notebook can even lead to the Think Award, which specializes in the best documentation of the engineering design process. An impressive notebook is also crucial for receiving the Inspire Award, which is the best award you can receive at any event. Additionally, good documentation is also crucial for sponsorships. Many different grants within the FIRST or robotics community, such as RevAmped Robotics, offer sponsorships based on engineering notebooks. While some sponsors may not require an engineering notebook, it could still be displayed and shown off to engineering firms and other potential sponsors, which will help set your team apart from others. Engineering notebooks can also be used for more than just awards and sponsorships. They can also be used for reflections regarding different parts, designs, and past competitions. Additionally, notebooks from previous seasons can also be used to see how their problems have been solved in the past and how traditionally you have built and machined different parts. Finally, notebooks are also really good to keep track of progress and for team management. You can use your notebook when looking back, similar to reflections, to see how long it's historically taken you to build a certain kind of part, so that will help you manage time. And it could also help you see what you have done in the past, so if you need to remake a part, you can easily go back and see how long that's taken you. As you know, there are 2 different types of notebook, a digital notebook and a physical notebook. A digital notebook is done entirely online and then printed out for judges. A physical notebook is handwritten and involves handwritten sketches. There are many different pros and cons for each option, and it's important to pick which one is right for you and your team. The right answer might even be both. I'm going to go over the pros and cons of each. So for a digital notebook, the pros are that multiple people can work on it at once since it is cloud-based, which those 2 are kind of connected. So that means it's more efficient, and if you have a lot of team members, that it would be easier to use. Also, if you happen to lose your notebook, you could easily replace it, just reprint it. And it also is really easy to edit, since if you make a mistake, you could just backspace. However, some of the cons are compared to a physical notebook, it's not as impressive to judges since it is easier to do in general. And you can't add hand drawings unless you scan them in or take a photo of them. And it's also harder to format compared to physical notebooks. And on that note, physical notebooks. It's a lot more impressive to judges since it does take a lot more time and effort, and it is easier to format. And you can also add hand drawings and sketches. But some of the cons are only one person can work on it at once. So if a lot of pages need to get done, it's really hard to do a lot at once. Also, there's no backups if lost or destroyed. So if you lose your engineering or your physical notebook, I should say, you're pretty much screwed and you kind of have to do it all over again. Or if you happen to like spill water on it or something. And the other thing is you can't really edit mistakes. You just have to cross them out, so it's not as visually appealing if you make a mistake. So, which one is best for you and your team? Well, there really is no correct answer. Personally, our team uses both a digital and a physical notebook, but your team might be better off doing just physical or just digital. If you have a lot of team members and some are interested in taking good notes and stuff like that and remaining organized, you might want to do a physical since it goes hand in hand with notes and being neat and organized, and it is more impressive. However, if you have fewer team members and less people interested in documentation, a digital notebook is easier to maintain. So it really is up to you and your team's wants and needs. Most teams like to keep their notebook as just one instead of having two, but our team personally uses both an engineering and a business notebook, engineering being physical and business being digital. And I'm just going to go over what is in each one and the benefits of splitting it up into two. So, in our business notebook, which is all online, and that way it's easier for us to edit, we have all our team information, outreach events, fundraising, finances, and our marketing information. And in our engineering notebook, we have brainstorming, CAD, fabrication, programming, competition reflections, and team managements. We like to split ours into two notebooks. This way, when the judges are looking, it is easier for them to distinguish which is which. And it also is better for stuff like the Connect Award since all our outreach is in one place and it's not mixed in with the engineering. Additionally, this means that we can have one person work on each, the business notebook and the engineering notebook, and one person isn't responsible for both outreach and engineering. Good organization is crucial to maintaining a good notebook and a strong team. It is important when talking about documentation, like all other aspects of robotics, that there's a hierarchy. For our team, we like to organize it this way. So our head of documentation is at the top, who helps manage both the business notebook and our engineering notebook. Then we have our business notebook manager, which is in charge of just the business notebook and everything related to that. And then we have our engineering notebook manager, who, as you guessed it, is just in charge of the engineering notebook. And then we have all other team members. Now, everyone is involved in documentation, whether or not they directly write a page in the notebook. So everyone is expected to report what they do every day to the engineering notebook manager and report all outreach events and finances to the business notebook manager. This just allows us to keep everything organized and neat. Additionally, our team uses Google Sheets in order to keep track of what everyone does each day. This allows us and the engineering notebook manager to know exactly what each particular person does on what day, if they finish, and if there are any photos associated with it. This means that if they have any questions or are unsure about what happened on one particular day or another, they can always find that particular person and ask them a question about what they did or to explain in more depth and detail. Additionally, our team personally uses team management software in order to keep track of what needs to be done and what we've completed. Our team personally uses Trello, but we've also experimented with Asana in the past, and we know other teams which use Monday.com and Scoro. This also is super important, especially for documentation, so you can keep track of what needs to be done and what has been done. This is especially useful when filling out Gantt charts or creating any kind of time management thing that you're putting in the notebook. When you first start documenting, especially with a physical notebook, it can be overwhelming. So here are some tricks and tips our team has learned through our many years of experience with documentation. So one of the first things, especially with a physical notebook, is to remember when you make any mistakes that you cross them out. Don't use whiteout. I know it's tempting, but don't use whiteout. And be sure to initial everything. This just shows judges and in a legal world that no one went back and edited your work. So be sure to do that. Additionally, when you're printing out CAD drawings or sketches, be sure that they contain the block at the bottom, which has the name of the part, the creator, and the date. Again, this just shows that you haven't gone back and edited the part or the drawing or taken out the picture. And it's also extremely important that whoever worked on physically writing the page signs it, and anyone who's around, like witnesses, also initials towards the bottom. We have everyone who attends initial the signatures, and anyone who actually worked on the notebook actually sign it. Again, most of this stuff is in the real world. You would do this for a legal document to prove ownership if you're filing a patent or other legal things like copyrights and stuff like that. So it's really important we also maintain these standards in first. Additionally, whenever you add photos, make sure to mark the edges of where you placed it. This way, again, it shows that you didn't remove it and swap out the photo for something else. Also, if you have any leftover space, be sure to cross it out. You should try to avoid having any leftover space, but sometimes it's inevitable. You don't have enough to fill a page. That's okay. Whatever you do, don't fit 2 days or multiple days onto one page. If you finish your day's entry and there's still room left, just cross it out. This just shows that no one went back and edited it and all that jazz. Also, I'm sure most of you guys know this, but be sure to write in ink. This way, again, if you write in pencil, you can go back and change it. Pen or ink is permanent. It is important that everyone is involved with documentation since it's such a huge part of being on a robotics team. While not everyone needs to directly write in the notebook, everyone should be involved in some shape or form. Especially when using an online or a digital notebook, everyone can be involved with writing it since it is cloud-based. And also, even if you have bad handwriting, since it is online, you can still write in it and upload photos and etc. However, not everyone needs to be involved directly with writing in the notebook and formatting and stuff like that. But everyone should be aware of what's going on in terms of progress, what needs to be done, and stuff like that. And while you might not directly be involved in the notebook, everyone still is involved in documentation, and they should be at least, by taking photos and taking notes on what they're doing throughout the day. This just makes life easier for any documenters since they have all the information they need about what has happened in a particular day. An important part of either an engineering or business notebook is the photos. Photos help you stand out and attract the judge's attention. In order to take good photos, you should include some of these things, such as renders, drawings, screenshots, and stuff from CAD. Judges tend to be really impressed when you have the correct drawings with the scale and the name and all that stuff. So be sure to include all of that in your drawings in the notebook. Photos of the parts in real life. So don't just have drawings and renders. Also be sure to take photos of them in real life. This is also good for promotional material when you're showing sponsors and other interested people who come to outreach that this is something we designed and this is it in real life. Also, it's important to have people working. Again, you might not have a specific place for this in your notebook, but it is really good if for promotional materials again, or slideshows if you want like stuff like that for outreach again, or your pit even. And also be sure to include screenshots from your code. And I have found that light mode is the best since it is easier to read and it just looks better on pages that are white at least. But when you include code, be sure that you explain it in detail and don't just stick giant blocks of code in, because the judges really like to see that you know what you're talking about when it comes to code. Additionally, with photos, avoid taking really blurry photos. I mean, sometimes that's all you have and that's okay, but avoid blurry photos, and also avoid taking photos of random stuff you don't really need. Like, be sure to take photos that matter and actually are important to what you're saying. So yeah. So now what most of you guys have been waiting for, the Think Award. So there are many important aspects which go into this award, which is mainly dedicated to the engineering notebook. So the Think Award is the award given to the team which best exemplifies the engineering design process. So some important things to keep in mind when writing in your notebooks is for physical notebooks, be sure to always write in pen and to cross out any mistakes and don't use whiteout or anything. Additionally, make sure to include math, physics, drawings, CAD, and stuff like that. This just shows the judges how you work through the engineering design process and work through your different designs. And speaking of the engineering process, it's important to show the entire steps of design, including any failures. It really helps show the entire journey, and judges love to see that not everyone's perfect, since in real life, not everyone is perfect. And finally, be sure to include a summary page. This is mandatory for the award, and make sure it includes details about both the robot and outreach. So our team likes to put the most important outreach events, one from each main area, so community, professional engineers, and education. So we like to do that. And we also like to talk about each main aspect of our robot, including output, input, extension, and our drivetrain. But that's just for this year, so it varies from year to year. And another important thing to keep in mind if you're going for the Think Award is flagging pages. Each team can flag up to 8 pages in both their business notebook and their engineer notebook, a total of 8 pages combined, that is. So this is just to help judges get a quick summary of your team, since the judges have many notebooks to read and they can't read all of them fully. So they look at the tab pages and really to get a good summary of your team. So it's important to try to have a balance of tab pages about engineering and business. This just shows the judges that you are a really well-balanced team. Even if your engineering notebook is 100 pages longer than your business notebook, as long as you have equal tab pages, it kind of shows that you're a really balanced team and you value each one the same. Also, try to pick the best pages to tab. So that means the ones that are the neatest, the prettiest, have the best colors, and the best photos and the most eye-catching. Also try to include pages that have math, physics, programming, and important stuff to your team. And also if you have a really big outreach event or you did something really impressive one day that no other team has done, definitely go for it and flag that page. The judges would love to see it, and it's a surefire way that they can't miss it. Finally, one of the most important things today is how to stand out. Every team has either 1 or 2 notebooks, so it's really important to show the judges that you are unique and you really put time and effort into your notebooks. So, some of the best ways you could stand out and be unique is to try to incorporate as many colors as you can. Of course, try to do this in a neat and organized way. Don't just make your entire page rainbow just because. But if there's tons of colors and when flipping through, it's eye-catching to judges, they will love that and they'll be sure to remember your notebook when it comes to picking out awards. Also, try to include many different photos. Try to at least have 1 or 2 photos per page. This way, if judges just need to flip through for a quick summary, like I said earlier, not every judge can read every page in your notebook. So if they flip through and they see a ton of photos, they kind of get a quick summary of your team and what you've been doing without really needing to read it. And this means that, again, they'll be more likely to remember your team and more likely to think that you captured your team's journey through the engineering design process. Also, another huge one is remain organized. If your notebook is all over the place and it doesn't have titles, if it's hard to follow, if everything's crossed out and everything is all over the place and writing's upside down and stuff, the judges aren't going to choose it. It might be the most amazing stuff. You might have the best robot and you might have definitely followed the engineering design process through and through, but if your notebook doesn't reflect that, you're not going to win Think or even Inspire. So it's important to remain organized with both physical and digital notebooks. And finally, try to use a format for each page to be consistent. Judges love flipping through and seeing that every page has some kind of format. This shows that you really thought through each page and you really aren't just sitting there doing it all the night before. For us, if you look at the top, for our engineering notebook, which is physical, we do a tasks reflections breakdown. So this just allows each page to start off the same way with kind of an overall summary of the day and what we did. And for our business notebook, which you could see below that, we have this generic format which just has our logo on the side in our blue color, and it also has room for signatures, witnesses, and the date. So again, this just allows us to be organized, and we also keep the titles and the dates the same with this too. So again, just having a neat format and being consistent with that format is super important, because again, it just shows that you're really on top of things and you know what's going on and you're not just kind of throwing things together. Even the best documenters sometimes deal with annoying things which make their lives a lot more difficult than it needs to be. So as a team for over 10 years, we've learned some of the most common mistakes and kind of figured out how to deal with them before they've become major issues. So here's some of them. It is important for everyone on the team to take photos during outreach and engineering times. If there's no good photos, it is difficult for the judges to see what's going on. While you could try and explain what's going on in as much detail as possible, pictures are really worth 1,000 words, and they really help explain stuff to judges, especially when it comes to parts or certain designs. Additionally, it's super important to communicate as a team. If the team and the documenter don't know what's going on, it's impossible to keep a good notebook. The notebooker should not be struggling and fighting with people to get information about the robot. That just means that their job is more difficult. Additionally, not taking screenshots and making sketches during CAD. It is important to show the progress of a design, and if there isn't photos of the in-betweens, it's really difficult to show progress. While it is possible to go back in time in most CAD softwares and take screenshots, it's just added work that is not needed if you just take screenshots while you're going. Additionally, on the note of CAD, it's super important that you have some CAD in your notebook or just in general in your team. Not only is it extremely helpful for preparation, it also helps show the judges that you know what's going on, and it helps the documenter also get a better picture for what's going on within the robot. As a team that has historically done well with the notebook and winning the Think Award, here are some common questions that we've got and some of our answers. So, how many notebooks should I have? Well, there's a limit of 2, so if you show up with like 50 notebooks, the judges won't look at them. But I personally recommend doing 2 notebooks just because it is easier for the judges to see your engineering and your business separated. Additionally, this allows us and many other teams to have their engineering be a physical notebook and their business to be all online. Having your business as an online notebook is a lot easier since you're constantly making changes to it, especially with finances and sponsors and stuff like that. And to do that physically would be a pain. And on the other hand, doing engineering physically is a lot easier, in my opinion, since you could sketch things and you could honestly show how you kind of worked it out in real life, but on paper. But you could always have one notebook too and just combine the 2. But I recommend 2. Next, can I use a 3-ring binder? Yes, you can. So you could use that if you have a digital notebook and you print it out. You could either hole punch the paper, or what we do is we use laminating sheets just to protect the paper to look kind of fancy. But you can also do that with like a physical notebook. So if you write on loose leaf, you could also put it in a 3-ring binder. Just be careful. There's specific dimensions on First website, so make sure if you get a 3-ring binder, it falls within all those dimensions. But yeah. Is there anything that I shouldn't document? No. The judges want to see your entire story, and that includes failures. The engineering design process is all about testing and retesting and adapting and analyzing and learning from your mistakes. So don't think just because you tried this idea and it completely failed that you shouldn't talk about it. Talk about it, but explain what you learned from it. There's nothing you shouldn't really document unless you spent an entire day cleaning or something. Like, okay, that's fine, but be sure to document mistakes. That's super important. Next, who sends the notebook? So I kind of touched on this earlier, but pretty much whoever worked on the notebook, or that one particular page, I should say, can sign that page as the writer or whatever it is in your particular format. And then a lot of times they'll also have a spot for witnesses, and for that, you could just have your entire team who was present at that meeting sign. Is there a limit to how many people can write in the notebook? No, there isn't. Judges love to see different handwriting, so it shows that it's a collaborative effort and it's not just one person writing in it. Now, of course, there's nothing wrong with just one person doing the notebook. However, as long as everyone has neat handwriting for a physical notebook, anyone can write at it. And especially if you're doing an online notebook, everyone should write in it, since there's no real downside if you have bad handwriting or whatever, and it's easy to edit. So yeah. And finally, what's the most important thing to include in a notebook? So it's really hard to say since all teams are different. However, in my opinion, the most important thing is to kind of show your team's story and your season progression. It's okay if at the beginning of the year at your first scrimmage, if you did awful, that's good. Judges want to see that at your first scrimmage you scored 2 points and now you score 50. They want to see improvement. So that goes along with the failures. Show everything. Tell a story, whether it be through your finances and show how you've earned more money over the months, or whether it be through your engineering and how your robot slowly evolved. It's really important that your notebooks tell a story and they tell the story of your team. You want judges to get to know you outside of the 10 minutes you speak to them. Thank you guys so much for watching. So Suffern Robotics has historically had really good notebooks. Last year we won the Think Award at every competition we went to, and this year we've won third place, Think. So if you have any questions regarding documentation, or you want me or one of our other documenters to review your notebook or anything like that, feel free to reach out to us on Suffern Robotics on all social media platforms, or you can go to our website, or you can email us at jordan@suffernrobotics.org. I look forward to hearing your questions, and good luck for the rest of the season.
Thank you again, Team 7486 Suffern Robotics, for a great presentation on managing documentation. Again, if anyone has any questions or comments for Team Suffern Robotics, please post them in the live chat. You can also contact them offline at any of these channels. And then our next topic is going to be on advanced programming by 9794 wizards.exe, and we will start at the top of the hour. Hey guys, sorry about that. We're going to be starting the next presentation in about 5 minutes. Welcome back, everyone. I hope you all enjoyed and learned from that last presentation by Team 7486, Suffern Robotics, on managing documentation. Our next topic is advanced programming, presented by Team 9794, Wizards.exe from Maryland. As always, feel free to be putting your questions in the chat, and without further ado, I'll hand it over to them.
Hello, everyone, and welcome to the Advanced Programming presentation and section of the WorldShop International FTC Conference. I'm very excited to share some of my experiences with you guys and introduce some key concepts that can really take your programming and your robot software to that next level. So my name is Sarthak, and I've been the software lead on FTC Team 9794 Wizards.exe for the last 5 years. And so I'm just going to share some of my experiences with you guys, some of my expertise, and hopefully you can apply that on your own robot and in your team to really help improve your robot performance going forward. Now, just before I start the content of this presentation, I just want to give a quick introduction to my team. So as I said before, I'm on FTC Team 9794 Wizards.exe, and we're a fifth-year robotics team from Rockville, Maryland. 2 years ago, we won the Inspire Award at the Detroit World Championship, the FTC World Championship, and our team's mission is to engage, expand, and educate different communities to promote STEM and FIRST through our various outreach and training programs, just like this World Shop International FTC Conference. Now, before we really delve into the details of our presentation, I just want to briefly talk about the high level concepts that we're going to cover today. This presentation will be, I'm guessing, around 30 to 45 minutes long. We'll see how it turns out, but that's my ballpark for the presentation. And we're going to discuss two main areas: programming options in FTC and some advanced concepts involving sensor fusion and advanced sensor integration. Both of these areas are very key to having a strong grasp on the FTC programming system and being able to develop advanced software. We'll talk about the three programming options available to teams, and specifically, we're going to explore the power of block programming and how it can really transform your team, just how it has transformed my team, Wizards.exe. And then following that section, we're going to move into the sensor fusion and advanced sensor integration section, where we're going to discuss and talk about why sensors are so important for your robot, common applications and common sensors that FTC teams use, and then taking the next step to go to advanced implementations and features to really take your robot's performance and your software development to the next level. So it's key to understand the different role that your programming language and how you implement different hardware and electronics to really take your programming from a more common or basic level to really the next step to get to the advanced programming level. So now we're going to start out with programming options. So you may be familiar with all three of these options, but I'm just going to walk through them. So we have three options available to FTC teams. The first is the block programming language, which is a simple drag and drop software, similar to Scratch if you've used that, but you use that simple drag and drop software to program your robot. You can use this for autonomous, for teleop, for anything. I'm going to talk about this a little later, but block programming, it's has a lot more power than people think it is, but we'll get into that in a little bit. The second option is onboard Java, which is kind of that Java environment built into the phone. And the main purpose is that it reduces the compile time. Just like blocks, it only takes blocks is instantaneous to save programs on your phone. Onboard Java, from my experience, takes 3 to 5 seconds to compile your code onto the phone. And the third option is Android Studio. So in Android Studio, you use Java to program the FTC application, the app that you download off of your robot controller. But you program the FTC app, make your programs on there. And Android Studio also offers the added benefit of being able to import external libraries into your software. But we'll get into all that a little later in the presentation. But those are your three options available to you guys. I personally have a lot of experience with block programming and Android Studio, and they're both very powerful, both very useful for lots of different applications. So why don't we get into that? I'm just going to briefly discuss the block environment versus Java. So as I mentioned before, we have a graphical programming language interface that is uh, block programming. simple drag and drop. You can see the different types of blocks you have here. You can run your programs in here, all of that. And the only really application that's required is Google Chrome. And or any really Google Chrome is recommended, but any internet browser works just fine. So that's really important to notice. I'm just going to hide the webcam so you guys can just see all the text real quick. And we have Java, which, as you probably know, is a text-based programming language. It requires some more background information. Generally, you should have a background information in any programming language, just the structure, object-oriented programming. And if you know one programming language, the syntax is relatively easy to learn for Java. But if you're starting from scratch, there's a relatively difficult learning curve in terms of acquiring the knowledge of the syntax, naming conventions, etc., that's required to program in Java. And then you can use onbot Java, like we discussed in the previous slide, but the most common way of using Java in FTC is through Android Studio. Android Studio requires a decent amount of processing power on your laptop. It's a tedious installation process, often with many complications. And then you're probably going to want to use GitHub, which is a version control software. We're not going to talk about GitHub and Git in this presentation, but if you would like to learn more about how you can use that in FTC, uh, please feel free to go on our YouTube channel, search up version control, and you'll learn how you can use GitHub and Git in your software. But that's not going to be covered in this presentation. Just wanted to give you that heads up. So, I'm gonna start out with some disadvantages to block programming. Um, you can't use external libraries, for example, OpenCV, which is a vision library, Roadrunner, which is a motion profiling library. We're actually going to talk about both of these in our presentation later on. So just it's good that I was able to name drop them there, but just keep an eye on those. But you're not able to use any custom sensors that are outside of kind of the default I2C configuration. There's no object-oriented workflow, so you can't really create any hierarchies or structures there. And the code can look like a mess when it gets really long. It's a little difficult user interface to use when you got a lot of code building up. But there are functions just like in Java in order to clean up the code. Um, and really, only teams that want to make advanced software kind of need these things. They need object-oriented workflows. They need custom I2C sensors. They need external libraries like OpenCV and Roadrunner. Um, and when we're just starting out, we don't really need these things, and this is why block programming is so powerful. You can make autonomous programs in this language. In fact, in 2016, our first few competitions, we used block programming to run our autonomous, and we were this was in Rail Recovery, and we still had a perfect autonomous there. It's very useful for prototyping. Just you can, instead of having your programmers just build up, having to have your programmers test out your different prototypes on the hardware. Um, you guys can make your own programs to briefly test motors, servos, sensors, those type of things. Since it's real simple and everyone is able to use it, it's very easy to learn as well. Um, which is really the big advantage. And until you need to get to the point to import libraries, create custom sensors, um, use object-oriented workflows, you should stick to block program. I think you can still use sensors. We developed a really great guide. It was targeted towards first global teams, but really any team can use it. You can see over here. Scan this QR code. We have some basic videos walking through the basics and fundamentals of block programming, and really shows you a lot of things are possible. You can make perfect autonomous programs. You can make really great driver controlled programs. It's all about those videos are all about how you can use block programming, and really the only limitations are taking that advanced step that we're actually going to talk about right now. So I really encourage you guys to check it out. Don't be scared or don't be timid to use block programming because you want to use Java. You think Java's cool. Block programming is just as good, just as efficient, just as powerful. Um, so go ahead, check out those videos if you guys want to learn more about block programming. But now we're going to move on to kind of the key point of this presentation. We want you guys to be able to take that next step into advanced programming. And a lot of that revolves around using different sensors together. That's what we call sensor fusion. And kind of advanced applications of those sensors in themselves. And that's really important for developing robots that have really great autonomous programs going above the basic things. But like in this year's game, You want to get a 4 stone or a 5 stone autonomous, you need sensors for that. You need advanced sensor integration. You need some of the libraries we're going to talk about. You want great teleop programs that make it really easy for the drivers to drive the robot. That requires sensors, that requires a lot of advanced things. So we're just going to briefly cover several of these high level topics, some of these sensors that you may want to use, and really help you take your robot's performance to the next level with advanced programming. So why don't we go ahead and get jump in? So I just touched on this, but the first step to advanced programming is sensors. Sensors allow the robots to be more aware. You can make decisions and react to in-game scenarios that you might be able not be able to predict. What happens if your robot hits another robot and veers off course? What happens if you run into the sky bridge, for example, in this year's game? How do you recover from that? Sensors allow your robot to make those decisions in real time because there are things that you're not going to be able to guess or predict that are going to happen on the competition field. And using these sensors and being able to use them properly leads to a much more consistent and reliable autonomous performance. And I think being able to use lots of sensors on your robot adds a lot more intelligence to your robot. I'm just thinking to last year or 2 years ago, my team personally, we used 20 different sensors on our robot, and we had a really great autonomous performance. And I think the really key difference between our team and other teams was how much we're able to use sensors in our teleop period, because that's what really separates the good teams from the great teams, the middle tier from the top tier. You got to be able to drive really quickly, drive really fast. Sensors will allow your robot to automate some of the difficult processes um, through driver controlled enhancements. And we're going to talk about that towards the end of the presentation. But I kind of just really want to get this key concept in your mind that sensors are the key for you to be able to elevate your robot, elevate your software to that next level. So, the premise or the basic starting point, I guess, for sensor applications in FTC is kind of bringing together a bunch of simple sensors. So you got motor encoders, you have ultrasonic or distance sensors, IMU, gyro sensors, color sensors. There are a lot more other sensors in FTC if you get my drift. But bringing those sensors together is very important. I'll just bring up one example. In autonomous this year, you can use motor encoders to move to different positions, drive straight 24 inches, pivot 90 degrees. If you want to pivot 90 degrees, you can use encoders, or you can also use your gyro sensor right over here. That'll give you a absolute frame of reference to pivot. It will make sure that if your encoders drift, your pivots aren't going to go awry and you're going to drive across the field or get penalties, all that stuff. You have to be able to use different sensors together to get a really consistent and reliable performance. Another example is if you're primarily using motor encoders to move, motor encoders have slippage. That's just a reality you have to deal with because your drive wheels, what if they run into something? They're going to slip. What if you're pulling the foundation in this year's game, but the foundation has a lot of friction and your wheels are just spinning? You could go for time, but that's not really the most effective way to do things. Ultrasonic sensors give you the option to measure distance from your robot to a fixed point of reference, like the perimeter, for example. So you can always measure your robot's position in real time. And that kind of takes you from relying on just one set of sensors to bringing together different sensors to allow for redundancy and just really, in general, consistency and an overall rise in reliability, which is really important for your FTC performance since autonomous is usually a really key component. You have to be able to have a really consistent and reliable autonomous, and bringing together different sensors is a really key aspect of that. I just mentioned this. Our team used 20 sensors over the last 2 seasons in a single year. There are lots of ways you can use sensors. There are lots of ways you can implement them to really make your robot more consistent and reliable. And then, kind of going from that next step, just from the simple sensors, is you want to cover some more advanced things. So we have vision systems. You can use your phone camera. You can use a web camera, like the ones you would use to Skype call or the one I'm using to record this presentation. But vision systems are really key. And this year, you have to identify that skystone target. In previous years, you've had to identify game. Sorry, excuse me. You've had to identify game elements or different kind of colors of your alliance. Its vision is really important in FTC, and it's only going to keep getting more important. It's going to be worth more points in autonomous. There are going to be more applications in teleop, and I think And I think that it's really key to have an understanding of these. So we have the phone camera on your Android phone that you can use. You have your webcam that you can actually put multiple on your robot. I'm just saying this because you can do this. You can put multiple USB web cameras on your robot. So we'll talk about some of the details revolving vision systems in just a moment. And really, the last advanced sensor application that we're going to cover is odometry. Odometry has taken a big leap in FTC. Odometry basically means how can I find my robot's position on the field? And then using that information, how can I go to different points on the field? But if you're able to keep track of your robot's position on the field, if another robot just slams into you, or if you hit the sky bridge, it doesn't matter because your robot will know where it went and how it can still get to its target position. We're going to cover that in just a moment. But let's why don't we delve into vision systems? I'm just gonna hide my webcam from you guys so you guys can see everything. Um, but again, computer vision is a huge component of autonomous sensing and scoring, and there are many options available for you guys for vision systems. You can use again the phone camera on that Android phone on your robot. You can use a lot of USB webcams, and to the biggest difficulty um, crossing the barrier for using Vision FTC is finding the right library that works for you. So I know I spent between 2 and 3 years trying to get really comfortable with Vision FTC. There weren't a lot of resources available to me to kind of learn from. I wasn't really savvy in OpenCV or computer vision, so I needed a really good starting point, and I had a lot of trouble finding that. And I think in today's state of FTC, there are a lot more resources available on how you can use OpenCV. DogeCV is a really great resource for starting points for FTC, and of course the Vuforia library. So in this year's FTC game, you can use either OpenCV, which is a open source library, computer vision library that allows you to do vision detection. You can identify different color objects, different sized objects, whatever you want to do. It's for object detection. Um, but DogeCV is a subset of that, I guess. It's a library developed for FTC teams. I was part of the development team for this, but they make easy ways for you to detect objects or complete vision tasks in each year's game. And in fact, if you scan this QR code right here, you guys can jump straight into a in-depth tutorial on how to use OpenCV, how to use DogeCV in your in your robot on your phone to be able to detect, for example, the sky stone this year. So our tutorials are game specific, and if you just scan this QR code right here or take a picture of it, just for future reference, you guys can really learn how to use vision to take your autonomous performance to the next level. And then, like I said before, you very key. They're an FTC partner or sponsor, so they're always going to be involved in the game. So it's always a great option to have going forward. And these libraries provide you with reliable vision object detection, which is of the utmost importance when it comes to autonomous. If you're not able to detect the sky stone correctly, you're losing 10 points right there because of that bonus you get for the sky stones. And 10 points is really hard to make up in teleop and endgame if you're down to another team. So it's really important to have that reliable vision detection. And OpenCV, DogeCV, and especially Vuforia in this year's game provide you that advantage. So go ahead, scan that QR code, take a picture of it. We're moving on to odometry. I'm going to spend a lot of time talking about this because this is probably the most important thing that I have personally done on my team. So I'm just going to cover a high level overview of robot odometry. So robot odometry calculates the position of the robot on the field at any point in time. And it does this by using an x, y, theta coordinate position. So your x, y, theta, it provides you three measurements. If you think of the FTC field as a two-dimensional field, your robot is just a point on that field. It has an x coordinate and it has a y coordinate, just like on a Cartesian graph. But then this theta coordinate is actually pretty important because your robot might know where it is on the field, but what direction is it facing in? Is it facing the building site? Is it facing the sky stones? You gotta be able to distinguish that. And so that theta, Greek letter meaning angle, is the third important key factor that odometry provides you. So you know where you are on the field and what direction you're facing. and that provides you a lot of options going forward to figure out what you want to do. And then you see, the way odometry works is that it estimates the change in your robot's position over a very short time frame. So I know FTC, their loop cycles are, it varies on teams depending on what you're doing in your autonomous program, but you're going between 50 milliseconds, 100 milliseconds. It's very short periods of time. So your robot's calculating how much it changes in position over that short period of time. It kind of accumulates that all together to constantly update your robot's position on the field. And the way that robot odometry works is that you generally you have 3 tracking wheels, or also 2 wheels plus an IMU or gyro sensor that keep track of your robot's position. So I'm just going to briefly explain that. Oh, whoops. I want to go back over here. So if this is our robot right over here, most teams that use odometry, they're going to have 3 wheels, 3 encoder wheels. Now, what do 3 encoder wheels mean? Well, this means that they're just they're not attached to any motors. They're just attached to your robot. So they're just kind of dragging along with your robot as your robot moves. Um, and that's an important feature about odometry because wheel slippage will not affect the measurements. This is a super critical advantage of odometry. And why do I say that? Well, that's because if your drive wheel slips, this wheel right over here, this wheel is not moving at all. Sorry, I should go back to my laser pointer. This wheel, it's not moving at all because the robot's not moving. It's not attached to a motor, so it's really going to enable the tracking wheels to measure the actual position of the robot and track its actual motion, opposed to if you're using motor encoders, the wheels are moving, but the robot's not moving. So the robot thinks it moved, but it didn't move in reality. So that's a common area. That's a really drastic improvement with odometry. But what I'm just going to quickly explain how odometry works. If you have let's say you have a mechanism drive, that's a good place to start. Your robot can move in any direction, so you need to have a wheel that is facing one direction. So we're going to call this just a vertical direction, and you have to have another wheel that's facing a horizontal direction, because if your robot moves at a 90-degree angle, like a mechanism drive, if it strafes to the right, this wheel over here is not going to move, but this wheel will detect that motion. So you need both this wheel and this wheel right over here. But what's this third wheel for? You might be wondering. So the way odometry works is that it relies on the angle of the robot. So, like I said, you can use 2 wheels plus an IMU and gyro sensor, but I think the best way to go forward is if you have 2 wheels, you can actually calculate 2 things. If your robot turns, one wheel is going to be going forwards, one wheel is going to be going backwards. Based on that information, your robot can calculate that change in orientation. And also, when you're going forwards and backwards or strafing a little bit, these wheels should be moving about the exact same. But if there's a change in angle, change in orientation, the wheels are going to be different. And being able to reconcile or use those values of both the wheels, it's really critical to having a very accurate odometry system. And that's kind of why you have those 3 wheels over there. So again, uh, we have 3 tracking wheels on the robot, if you can imagine that. Um, Either 3 wheels, or you can also use 2 wheels and a gyro sensor. Um, the 2 wheel and gyro sensor is more common amongst like tank drives, 6-wheel drives, but I would still recommend going with the 3 wheels because this third wheel right over here is very critical to being able to detect motion in that side to side area. If your robot either gets pushed sideways, or if you have a mechanism drive and your robot kind of just moves in that general direction on its own, just because it has that capability to move in any orientation, or sorry, any direction on the field. And the really key advantage of odometry is that it's extremely reliable. So imagine this is just a test I do, but if your robot is driving wrong and you push it to the side. If you have normal encoders, that's not going to be able to recover from that because it doesn't know that it's moved sideways, right? Because you're using encoders on the motors. But odometry picks that up because these wheels are not attached to the robot, so it knows that its position has changed. It can automatically detect that and continue moving to that same point. So if I have a robot um, that starts over here and I want to get to this position right over here, I could be driving along this path right over here. But what if another robot hits me? I'm going to veer off to the side all of a sudden. If you have motor encoders, it might think that I just want to keep going straight like I was before. But odometry detects that your new point is right over here, and it's going to just draw up a new path and go straight back to that target position because the robot knows its position has changed, which is really the powerful thing about odometry. I'm just going to go ahead and erase all this ink on the slide. Um, and what our team did is we actually used odometry last year. And I think one of the great things that teams have told us, mentors and other teams, is that a couple of years ago, you had a really top tier teams. Think gluten free. You had gluten free was up here. You had a top tier teams down here, and FTC here was everyone else. Last year, when we used odometry and figured out how powerful it was, how it could really improve your autonomous performance, we want to bring first of all, we want to bring that we want to close the gap between the higher tier teams and the rest of the FTC community. So we actually developed an odometry spell book, which is a series of 5 videos how you can build a drivetrain with odometry, how you can wire it up, and how you can get started programming. And in fact, we provide the code to you guys. We want you to be able to use odometry. We want everyone to be able to have that learning experience going forward. And it's really key because we want to bring everyone else up to those top tier teams. And so go ahead, scan this QR code, take a picture, take a look at it later. I know the season might be coming towards an end for some teams, but this is a really cool project you could work on during the summer, for example. Learn odometry, learn how to program. It has some really cool applications, and I'm actually going to talk about that right now. So, how can robots use odometry? So, I just talked about one way, which is that, whoops, I want a pen. If we're at point A and we want to go to point B, we know our position is right over here. The robot can calculate the path it needs to get to that point B, and it can drive along that path using odometry. And it can recover from any direct hits. So if we take a hit, we're going along our path, we take a hit, we get pushed to the side, it knows it can just recorrect that path on its own since it's constantly updating its position, constantly knowing where it is on the field. That's a really cool feature, I think. It adds a lot of intelligence to the robot. But you can take it one step further. So we have different path planning algorithms. Now, what exactly is path planning? Path planning is figuring out get how to form your paths in some of the most efficient ways possible. So um, let's take an FTC field, for example. This year's game, for example. You have some barriers, right? You have your quarry over here on both sides of the field. And you have this sky bridge right over here in the middle of the field that's a giant obstacle with barriers on the side, right? That's plenty of places for robots to run into, which is not fun. So I want to talk about A-star search. That's a really key part of a really cool application of odometry. So let's say my robot's over here. I want to pull the foundation, which is, I'm just going to say it's this line right over here. And I want to go over here and then go somewhere over here because I see a stone over here in autonomous. Well, there are 2 challenges to that. If my robot moves over here, if we go on a direct line, you can imagine this, we're just going to hit the sky bridge. But it would be cool if I could find a way to navigate around this fixed obstacle that is the sky bridge. Well, lucky for you, A-star search is the perfect place to start for that. Because what A-star search does is if you give it a kind of a grid or a graph of areas you can go and areas you don't want to go, the robot can automatically calculate the most efficient way to get there. So let's say my robot is right over here. I'm the star and I want to go to the circle. But let's say that there is an obstacle right over here and right over here. Now, if you're just using odometry on its own with a point A to point B kind of space, it's going to want to think to go right over here, but you're going to run straight into this obstacle. And while your robot knows it ran into the obstacle, it can't really do anything about it, right? But what we want to do is we want to be able to navigate around obstacles, which is why A-star search, what it does is it explores all possible paths and figures out the most efficient path to go on. It's very similar to Dijkstra's algorithm, if you know that from maybe a computer science or programming class. But what it would do is it tries possible algorithm or paths. So it could try this path, but again, it runs into a no go zone. It could try this path, but again, it ran into this zone right over here. And after trying a bunch of different paths, it's going to know that the most efficient path, and in this case, the only path to your target position, is to take this L shape right over here to kind of go along this direction. So that's just one way of using A-star search. We developed that for our robot this year, and it was super cool how the robot's just kind of able to go around a variety of different obstacles. And what you can do is, if you take the FTC field, for example, sorry about this. If you take the FTC field, divide it up into a grid, and just say, I can't go here, I can't go here, I can't go here. But you can go in all these other places. I'm just making more grids for myself. But you can go in all these other places. The robot can figure out if it's over here, I want to go over here, I'll just take this path. That seems like it's the most efficient. So you want to be able to use A-star search to be able to do that. And that's, I think, a really cool step from odometry. You figure out how to move to point A to point B, but how do you navigate intelligently? That's a really important aspect to this. All right. Odometry also enables you to use a peer pursuit controller. I'm guessing most of you guys aren't familiar with the peer pursuit controller, so I'm going to go a high level overview. So let's say using odometry that I'm starting over here, I want to go over here, and then finally go over here. You could do an abrupt motion, something like this, where you go point A, point B, point C. But that might not be the most efficient way. And what happens if I'm starting facing this orientation, but I want to end up facing this orientation? Am I going to have to move, do a pivot, then move again? Am I going to move, and then pivot again? It can be a little complex, and it can also be a little inefficient. Because keep in mind, any robot, the best way it moves is if it's facing in the forward direction. So if you want to be going as fast as possible, you always want to be moving in that forward direction. And what kind of pure pursuit enables you to do is, I'm going to draw it in green over here, but it enables you to go to this point, but then you realize I need to go to the next point. So it starts turning. It does a curve motion and it gets to that target position. And the way it does this is you can think about the robot as a circle, and it's constantly finding intersections of the line, and it's looking ahead to the next point. But over here, if I draw a circle, I don't I intersect with this point next, right? So I want to go from this point to this point, bypassing this point right over here. You can see the radius of this circle enables that. So you kind of want to you that kind of idea or those calculations creates that curved motion that you follow to your next point, which is really cool. It's kind of like a car driving, if you can think about that. You're doing turns, not pivots. It actually really speeds up your efficiency, which is really important for really quick and fast autonomous performance. If you think about some of the teams this year, gluten free, Cubics, some of the other really high level teams, they use this kind of stuff to be able to move quickly across the field. Because getting 5 stones or 4 stones in autonomous, it requires lightning fast motion, and you have to be able to get that, which is why peer pursuit is a cool extension of odometry, which is something you need first of all before you head on to peer pursuit. And the last thing I'm not going to talk about too much because I personally don't have too much experience with it, is the Roadrunner Path Planning Library. This allows you to plan out trajectories, do really neat curves, splines, that kind of stuff. Um, there are some resources available online. There's awesome documentation, but that's something you can use if you have odometry and you want to be able to kind of do cool curves, navigate really fast on the field. Explore using the Roadrunner Path Planning Library. It's really useful for FTC teams. It allows you to do some really cool motion profiling. And yeah, So those are some kind of extensions of odometry 3 examples of implementing intelligent path planning algorithms. And like I said, I really want you guys to be able to do this on your robot because it's an amazing learning experience. Being able to apply this in a competition setting and take your robot to a competition, knowing that it's the smartest robot on the field that can really do autonomous really well. So I really want you guys to check out this spell book. It's got 5 videos again, so that I can walk you through step by step for getting odometry up and running on your robot. And it's actually a much more simple process. I'm going to remove my webcam so you guys can scan the code. I just realized my webcam was covering it. But you guys can do that right over here. And most teams just use odometry in autonomous, but you can actually use it in teleop as well. I'm just thinking in this year's game, imagine being able to drive across the field and go to the position you're stacking blocks autonomously. You can do that with odometry because drivers take a lot. There's some bad drivers out in FTC. I know that our team is not the best at driving, which is why we use a lot of these automated enhancements to go from maybe say the sky bridge to the stack we're stacking on the stones. And this way, you eliminate the time you're lining up. It's a lot quicker than a human driving it. Robots are a lot better doing things themselves than humans are. That's just a reality. And you can use odometry and teleop for automated driver enhancements to kind of really speed up your performance, make things a lot better, take your team to the next level. So hopefully that gave you some ideas on how your team can implement and use odometry um, on your robot. Whoops, I accidentally changed this slide. Sorry about that. Um, yeah, so hopefully you guys are able to learn from that. It's really key to be able to once you use odometry, how can I take it to the next step? So these videos will walk you through getting odometry, and there are lots of online resources for kind of advancing to A-star search, peer pursuit, and using the Roadrunner path planning library. Um, and then the last thing I want to talk about, it's kind of an extension off of odometry and that kind of automated driver enhancements we talked about, is kind of bringing together a bunch of different sensors and combining the different sensors for greater consistency and driver enhancements. So let me just think about some common mechanisms. So this year we have an intake. What if the intake automatically turned on when a stone was in front of it? Well, guess what? Sensors enable you to do that. What if your driver forgets to turn on the intake? You're going to waste time trying to realize that your intake is not on. You can bring together different sensors, like maybe some distance sensors, ultrasonic sensors, color sensors, to detect when a stone is in front of the robot. And maybe if you have a active intake, a wheeled intake, those will automatically turn on. That way, if your driver forgets, or if your driver is preoccupied with something else going on the field, the robot can take care of some of those human errors that are happening. So sensors are very important for implementing driver enhancements, and using sensors can drastically speed up performance and scoring in teleop. If the driver doesn't have to do everything and the robot can help out the driver along in the process, the driver just has to go from point A to point B, press a couple buttons, and you're done. You don't have to worry about controlling complex mechanisms. For example, difficult operational tasks can be drastically simplified. If you have an arm that's moving in like 3 or 4 degrees of freedom with a wrist or a claw or something, that's a lot of buttons on a gamepad. And that's really difficult for a driver to control. Using motor encoders, using advanced trig on your calculations off gamepad inputs can really simplify the process. You want your robot to do thinking in teleop, not just in autonomous. In autonomous, it has to be able to do everything on its own. In teleop, you have the option, you could say, of adding a driver. But really, if you can automate as much stuff as possible, your robot's going to be really quick and really fast and really high scoring, and you guys are going to kind of take that robot performance to the next level. And perhaps one of the more important thing is that sensors can correct human errors. Another application of sensors in this year's game for driver enhancements is if your robot can detect if it has two stones. Let's say I have a distance sensor right over here and a distance sensor right over here, and there's a stone in both locations. I know the robot will have a stone. I know the robot has two stones, and I can just start ejecting them. I can spit out the stones. Um, that will correct the human error on the driver. It will help you score faster, and it will help you from accumulating penalty points, which is obviously important if you want to win a match. So that's just something to think about. And I actually have a pretty cool thing right up over here, a video from 2 years ago. This is our robot from 2 years ago. I'm going to switch off my webcam so you guys can see what's going on. But I'm just going to start the video, and you'll see. I'm just going to walk you through some things that the robot's doing. So, if this video will start. Oh, it looks like we are having some problems. I'm just going to take a quick look. I'll just show you guys it like this. But if I play the video, you're going to see the wheels turn on to intake the block. Now, what happened automatically was the wheels stopped, the lights turned on, and the lift came up. Now, why are those three things important? The lights let well, first of all, the wheels stop. This prevents us from damaging the block because the drivers might not be able to see when we have a block, and they won't know to turn off the intake. Sensors automatically do this for us. And if I rewind this just a little bit, you can see there's one sensor over here, and there's another sensor back behind this block. So you can detect those two blocks. And my next point is if the driver can't see if we have a block or not, these LEDs right over here tell the driver that. So once the block is in, the LEDs turn on, drivers know they're good to go. They can start driving away from the pit and go to stack those blocks. This is from 2 years ago, just for you guys who don't know the game from 2 years ago. But what's another interesting thing is once the block comes in, I'll play that clip again. Once the block comes in, the lift automatically goes up, which means that the drivers aren't dragging anything on the ground, which is a pretty cool feature. Because the driver might not be able to react in real time as fast as the robot can, since it has the sensors to do that. So that's just a really cool aspect of the driver controlled features. And in fact, so in the year we developed this robot, we actually had our whole mechanism flip so we could pick up two stones on top of each other. And if you think about that, if a driver's doing that on his own, he has to, what does he have to do? He has to lift the lift, he has to spin that servo, and he has to come back down. That's a lot of processes. It can be, you can make errors that cause hardware damage and some wiring issues. It's a lot easier for the robot to do that on its own. So what we actually did was using the motor encoder on our lift, again, another sensor and the color sensors, all the driver has to do is press one button. All the driver has to do is just press one button. It automatically lifts it up, it flips it, it comes back down. You need sensors to be able to do that on your robot. And I think I'll just play this clip again while I talk. But using sensors, this is just one example. There were 20 sensors on this robot, and being able to use those sensors to help the drivers is a really critical component, just as important as autonomous. Because if you can score really fast in autonomous, or sorry, if you can score really fast in teleop, it provides a huge advantage to your team going forward. And I think that being able to bring together those different sensors, kind of sensor fusion, the concept of combining different sensors, will give you greater consistency. It will give you redundancy, but it will also make it a lot easier to drive your robot. Robots are complicated machines. They can be very difficult for humans to operate. Sensors will help it make it easier for that. There are lots of ways. I'm sure you guys can brainstorm different ways for your robot to do things like that. But sensors allow you to correct for human errors. They automate processes, make it a lot easier for your robot to go along. But yeah, that's about it that I have for you guys. Oh, of course, the video plays now. But hopefully you're able to gain a lot out of this presentation. Um, Hopefully you were able to understand some of the ways you can program an FTC, the power of block programming. I cannot stress that enough. It transformed how our team operates. I suggest you guys do the same. Go back, take a look at that QR code, take a look at those videos. But the power of block programming, and then moving on to some of the advanced things in FTC, odometry, vision, advanced path planning algorithms, libraries like OpenCV, DodeCV, Roadrunner. Those are really great ways for you guys to take your robot to the next level. How you can really elevate your programming and your software. Um, Before we end, I just want to take a chance to thank some of Wizards.exe's gold sponsors: Lockheed Martin, BAE Systems, Abbott, and Pepco. These companies really make our team's operation possible. I wouldn't be here giving you this presentation. We wouldn't be able to develop our awesome video series that you guys should check out without these incredible sponsors. So I just want to give a quick shout out to them. And thank you guys for watching. I just want to give a shout out to the organizers of the WorldShop International FTC Conference. It was an amazing experience being able to share some of my experiences with you guys and introduce some really advanced and seemingly intimidating concepts that can take your programming to the next level. But in reality, it's not that difficult once you really break it down and really dig in. And again, that's what our videos will help you do. I'm just going to go back in the presentation. If you want to take a look at our block programming spell book, scan the QR code right over here. I'll leave this up for a few seconds. Scan the QR code if you want to check out our awesome videos. We have our Vision Spellbook series. It'll teach you how to use DogeCV, OpenCV, and Vuforia, all in this year's game. Take a look if that interests you. And of course, odometry. We have a 5-part video series to highlight the key aspects of odometry, how to get it up and running, how to program it, everything. So take a look at that. And yeah, so thank you guys for listening to this presentation. I hope you were able to gain something out of it, whether it was the importance of sensors, how you can think about using odometry on your robot, just how to think about using different sensors. Hopefully, you were able to gain some of that, and I hope that you guys are able to implement that on your own robot, whether it's for this season or seasons in the future. I know that we're ready to take questions now, so hopefully you guys were following along. If you have any questions, we'll be happy to answer them. If you have any questions following the after this conference, you can contact us at wizards.exe@gmail.com. You can reach out to us on social media. You can look up our Twitter, Instagram, Facebook, whatever. And then you can also contact us on our website and just catch up on what our team is doing on our website as well. That's wizards-exe.weebly.com. Thank you guys so much for allowing me to share my expertise and experiences with you. And I hope that you were able to take a lot out of this presentation and apply it forward. Apply it on your robot in upcoming seasons. Again, thank you guys for listening.
Thank you again, Team 9794, for a great presentation on advanced programming and odometry and vision softwares. Now, if anyone has any questions or comments for Team 9794, wizards.exe, please post them in the live chat. You can also contact them offline at any of these channels. Our next topic is we're going to be taking a 30-minute break. So we're going to be resuming at 3:30 p.m. Eastern Daylight Time, and we'll see you guys then. Thank you. Obviously, in the meantime, in that break, you can keep posting your questions and comments. Welcome back, everyone, from the break. I hope everyone has been learning some useful information and tips and has been enjoying the presentation so far. Let's jump right into the next set of presentations. And the next topic is effectively planning your FTC season by 12528 Next Gen from Minnesota. As always, feel free to be putting your questions in the chat. And without further ado, I'll hand it over to Next Gen.
Hello everyone, I am Rebecca, a member of 12528 Next Gen, and today I have the pleasure of presenting in the FTC WorldShop Conference. Before I get started, I want to just give a thanks to all the teams that put the time and effort into this event, and I'm so thankful that I got this opportunity to work with these amazing teams. Personally, it's my favorite thing to connect with other teams and mentor, so I'm really excited to see how all of our presentations turn out, and I hope these can be a resource for you guys in the future. Today, I will be talking about how to effectively manage your season with everything that you have to do and complete before tournaments.
So we are Team 12528 from Apple Valley, Minnesota. This is our third year in FTC, but we have many years of first experience combined. On the far left, there's Lisa, and then Ria, Jacob, and me on the far right, Rebecca. We started FLL during the Food Factory year, and we were a team for 5 years as the Diamonds. Then we joined FTC during the Relic Recovery year and competed in Rover Ruckus as well.
Now that I've kind of given you guys some context to behind my team, let's go ahead and jump into managing your FTC season effectively. I'm going to start off with the time management basics and where every team should start as far as beginning your FTC season. A phrase that our team uses as a reference for our overall season is knowing where you want to end up and then figuring out a way to get there. This will be the overall theme I'll be getting across today, as well as a basic lens every team should use when going about their season and season planning. The first thing to managing your FTC season is to start off by coming up with goals you want your team to accomplish by the end of the season. These goals could sound like we want X number of outreach events by the end of the season, or we want a thorough in-depth notebook. Either way, goals are the building blocks to your team season and will lead you to what sort of things you end up doing. Remember that goals are also specific to your team, so don't worry about measuring up to other teams. But use your goals to improve your own team. Make sure they revolve around your team's identity before anything else. Your goals can focus around your team's interests or areas you might need to improve on. A couple things to keep in mind about goals is that they should be specific so they can be achievable. For instance, say your team's goal is to do more outreach. Okay, that's great, but it's not specific. If you're more specific about your goals, it's easier to know where to begin. So you could say we want to do at least 10 community outreach events and mentor at least 8 teams. That's both specific and you know where to start. Goals are extremely important because without them, you don't have an idea or vision of what you want to achieve or have as your final product. So, goals should be the start to every season.
Something new that we added to our notebook this season that really impressed some of the judges this year at our tournaments was our season sustainability projection plan. This was a 3-page part of our sustainability plan that detailed some of our goals specifically for our team, our robot, and our outreach sections. It went through different areas like what kind of outreach events you want to do and just kind of really detailed everything that we were looking for in our team season. We completed this at the beginning of our season before kickoff, and then we used it as a reference throughout our season. I think that it made our notebook stand out compared to just other notebooks that are like, these are our goals, or these are our like things that we want to do, because it was so different and unique to our team, and it was just very easy to kind of see what we were talking about and what we were trying to explain because we were so specific in it, which is something I already hit on. But as you can see here, we run through every single part and we categorize everything, and then we kind of do a summary at the bottom. One thing that if we were to compete again next year that we could change about this is we'd probably have a summary for each of those pages, so then judges can kind of look through it more easily instead of having to read paragraphs, considering that's kind of a thing some teams want to not have is a ton of paragraphs, obviously, so judges can look through it quicker. But this is kind of a general idea of what our team used and took on for goals and planning.
The next step is knowing your starting point and potential. This means knowing your resources, time limits, availability, and anything else that factors into your team's success, both good and bad. You should go into the season knowing what you're capable of, and not making obscure goals that don't make sense because they don't line up with your starting point and/or position. The last thing to consider when putting together your goals is that they won't magically get done and completed by the end of the year. It's your team's job to create your goals and then have a plan to get there, as in having a plan to achieve all your goals. These plans will help you to sketch out what your season should look like, so then you're setting yourselves up for success. It's about getting from point A to point B. By doing this, it's a good way to see where you're headed instead of just going about your season without a clear plan. This way, you know what success looks like for your team by the end of the year. Your team's job is to fill in the middle between point A and point B. This could look like we want at least 10 outreach events done before October, and we want the majority of our robot built 2 to 3 weeks before our competitions. The way you can follow your plan to complete your goals. You could also look at it like a timeline to follow. The major benefits include being able to see the dark spots or question marks to your season. These dark spots could look like projects you want to complete but don't really know where they fall into your season, like designing your pit appearance or creating your promote video. These things could be completed at any time, but you don't want these tasks to be forgotten and then need to be dealt with a week before competition or the night before. So, if you can plan out when you want to complete these tasks before crunch time, you can avoid having a pile-up of work when it comes down to the weeks and days before competition. Specific examples of how our team effectively uses this is we made sure to get a promote video done by the end of October, so we could focus on more and other important things during crunch time. A way we didn't effectively use this is we didn't plan on creating our team summary page by any certain date, so we were scrambling to complete it a couple days before competition. This is something we have learned from, and we know to get it done on an earlier date. So it's important to have a plan on working on your goals and being able to fill in those dark spots that need to be taken care of at an earlier date. Next is assigning roles and dividing up the work. I strongly believe in assigning roles and dividing up the work. Coming from a team that only has 5 people, it was a challenge with the workload and level we were competing at. So we found that assigning roles and dividing up the work became a very effective and efficient way to get things done. Assigning roles could look like giving each person on a team an area that they have oversight over to make sure everything gets done. This helps for managing your workload throughout the season. Our team divided up the different areas like notebook management, professional connections, budget keeper, programmer, and builder to teams of 1 or 2. This gave everyone their own area that they got to be an expert in. They would use this as an opportunity to learn everything about that area and then teach others on the team about it. To specify, I do not mean a single person would take control of an area all by themselves. I'm just saying that you could assign people to manage each area to make sure things get done. By dividing up the roles, you are also dividing up the workload to different areas to different people. This avoids having a single person on a team getting all the pressure to manage everything. Once the basic workloads are divided into the different areas, you work as a team to complete all the tasks together in the different areas. A little bit further into the workload divisions is when work is taken care of. Our team finds it effective to get important priorities done during meetings and then assigning work to individuals to complete outside of meetings. This lets people take care of their own work, so you're not wasting any team time that could be used for other projects like building, drive practice, and presentation practice. It's your team's choice to see how they divide up the work. Of course, this is our team's preference, and every team is different, so take this information if you believe it would suit your team. Marking down commitments should be a number 1 priority to your very first meetings of every season. You should all know when each member is available and busy. This helps in the future because you can plan around these unavailabilities to get the best team turnouts to meetings and outreach events. Mark down the big things like sport commitments, family events, and school activities. By marking down these dates where team members are already busy, you can plan around them and avoid future problems. True life hack for FTC teams. On the other hand, if you can't mark down every team member's conflicting event, it's okay. There are other ways to deal with it, like communicating before. Because remember, communication is key for successful teams and full team turnouts. And I cannot stress this enough. This is an area all teams can improve on. I believe communication is very important, and it should be the key focus for every team. Without team communication, you aren't going to get anything done. Communication is important because it builds relationships on your team. You can connect more if you talk and share ideas. For the robot and design, communication is key to facilitate innovation so you can get to the best design possible. The only way your team can grow to become an effective and successful team is communication to make sure work is getting done. Communication comes in handy when talking to businesses for sponsorships, or talking to teams at outreach events, or scouting for competition. So as you can see, communication is the center of FTC and should be a key asset of all teams that is constantly improving. Your team's outreach is one of the many important parts to your team's journey and overall success. Therefore, when you manage it, you should manage it like your life depends on it. I believe outreach can sometimes be one of the more messy areas if you're a new team because you're trying new things and new events that you've probably never done before. So it's good to manage it very organized, and that's where having a plan for your goals with outreach ties into this area. Let's begin with how to go about doing outreach. One of the biggest problems that we face with doing outreach is that our season after kickoff, everything ramps up, as in notebook and robot. But one thing teams don't plan for is that school ramps up, and family, and sports events, and plays, and swim team, and hockey tournaments, and vacations, and homework is a huge conflict for a lot of teams. So it doesn't make a lot of sense to plan all of your outreach events after kickoff. Keyword all. Because everyone gets so busy after kickoff with everything, it might be wise to start planning your outreach events before kickoff in the off season. We recommend doing a decent amount of outreach in the summer before season kickoff because there's more time and flexibility because your team isn't cooped up in school for 6 hours every 5 days in a row. So, we recommend outreach in the off season purely because everyone is not that busy. One outreach event that our team has done for 3 years in a row is called the Apple Valley Invitational. This was an event that we did in August before our season started, where we invited different teams from around our area to come and demo in our neighborhood. Personally, our team likes these types of outreach events where other teams can make an impact on the community because we're giving them the opportunity to do that where they might not have the opportunity in the first place. I think this helps stand out because you're doing something more than just an individual team impact, but you're growing your impact in your community, and that's really important too as well for a team. So being able to bring other teams into your outreach and be able to initiate events where you can have other teams participating is something really cool that your team can do as something new or different. The other really important thing about this that I think is missed is that you're actually being able to create new relationships and connect with new people. Instead of just trying to get like the number of people impacted or the hours overall, you're actually building really important relationships that you can continue on past robotics and you can keep with these people. And so one way that we built relationships in kind of a fun, spontaneous way, that's just interesting, was we had a hockey game running that night and we had different teams playing with each other and running around the road and just having a fun night and making memories in the program, which is something that our team values really strongly. And I think when judges ask us, like, what's the most important thing to first for you, or like, why would you join first, or why do you continue in this program, it's about making the relationships and continuing to impact people and like make new memories and have new experiences. And so that's just one part of it. One more thing that we did that night was we all had a dance line and we were all dancing the Cotton Eye Joe and just all those fun dances that you do at tournaments and as with other people. And just as a side note, everyone should know these dances, and I'm talking about the YMCA, the Cotton Eye Joe, the Cupid Shuffle, the Macarena, and every other dance out there, because you never know when you can start dancing on the floor. And if you don't know those dances, go on YouTube right now, watch them, then come back to these presentations, because you need to know these dances. After you've watched all these presentations, the dances are way more important. But anyways, back to outreach, back to making an impact. Getting your outreach events done in the off season is also very important, and you should be focusing on doing that so you can spend more of your dense season kickoff time working on the robot, working on your notebook, and you can kind of get a lot of that outreach out of the way at the beginning of the season, and you can focus your time on other things later. After considering outreach in the off season, let's bring up the fact that teams should be planning outreach events in the future, at least a couple months in advance. This helps to work around scheduling, conflicts, and anything else that could go wrong. You can plan mentoring sessions and business meetups and all sorts of things. But remember to get on those right away so you have them worked out for your season. Another thing to tie into managing your outreach is that outreach events don't fall into your lap. You have to find them, create them, and do them. I'm going to highlight the create them part because this is also the aspect to outreach that separates your team from other teams at competition. Initiation is a huge thing for outreach, and it's important that you get out there and start making a presence in your community and that you're reaching out. An outreach event that our team initiated this year that we've done for 2 years in a row now is an event called Out of This World. Out of This World is an outreach event where we are able to impact teams in Minnesota by Skyping in teams from around the world to present and share their knowledge and experiences that teams in Minnesota couldn't provide to each other. So we were kind of trying to find an event that would make our team stand out or kind of be something unique and different, finding something kind of different and never done before, never seen before. And our team really enjoys doing this Out of This World event because we're able to connect teams from around the world to the teams in Minnesota, which is really cool. But we also brought in engineers and professionals to our teams to give them design reviews. And sorry, I only have one photo of this event on my computer right now, but if you can see between the heads, there's some robots on the tables, and those are the robots they're looking through. But anyways, Out of This World is a cool event that we initiated and made us stand out and had a strong impact. If you do plan on creating your own event, make sure you have plenty of time to sort out the details and work everything out before your event crunch time. In conclusion, we recommend outreach in the off-season and plenty of time for planning any events that you want to complete. As far as organizing and separating and categorizing our outreach, our team split into two different main categories. Of course, we had smaller different areas that we would use to divide them all up, but our main areas were professional outreach and community outreach, kind of going back and forth between connect and motivate. That just helped us be able to see the wider view and bigger picture of our outreach, and also be able to see the small nitty-gritty details where everything connected together. One thing that I'm just going to touch on really quickly is that this season our team happened to focus a lot on our Motivate outreach. We did a lot of community events and a lot of impacting other teams and mentoring, and we didn't do as strong in the Connect area as we have in other seasons. And I think that in the long run that actually kind of burned us a little bit because we weren't able to compete at the same level as a lot of the other high-level teams because we didn't have the same amount of Connect outreach as other teams. And when I say the same amount, I don't mean like the number of hours or the number of events, but we just weren't as strong as other teams, and then we weren't able to compete at the same level. So something to keep in mind is the balance of connect outreach and motivate outreach you have, making sure that you're not leaving one out because it's either like harder to do or it's just not your favorite, because if you want to be a competitive team, one of the biggest things is being able to be well-rounded and being able to be strong in all the areas. And when you get to those specific details like connect and motivate, it's really important to be strong in both. And then also being able to explore the differences in those two, or being able to explore different paths in those two. Like connect outreach doesn't just mean like meeting up with professionals or going to companies, but it also means like investigating tours or new opportunities or trying different things and finding a little thing to make your team stand out in the long run. So just something to keep in mind if you're competing at a strong level, or something to remember. Something that a mentor taught us this season to keep in mind is that for the majority of your outreach, you're going to want to be doing a lot of focus on how you're creating first in your community and how you're creating the opportunities for first in your community. And by that I mean you're not just doing events that sustain first. And the difference between this is how your team is putting first into your community. How are you starting teams or starting new activities or going to local libraries or putting first in the community that not already is there? For the past 2 years, our team has been really good about the sustainability part. We've been doing lots of going to schools that already have teams and strengthening their programs. And when you go to different teams and you're mentoring them, and that's something that our team is strong at. But a way that we kind of had to develop and grow out of it is how are we creating or initiating first in our community. Something new that our team did this year was we went to the Minnesota Autism Center, and that didn't already have first in their curriculum. So we met with their representatives and we talked to them about first and what it meant to us and how they could implement variations of it in their school for their kids, because autistic students are obviously a group of people that aren't exposed to first as heavily as some people might be. So something to keep in mind if you're a second or third, fourth year team, how are you going beyond just sustaining first but initiating first in your community? Managing your robot design. The worst thing that can happen is that you run out of time, so don't make time your enemy. Running out of time can be a team's worst defeat that they didn't see coming. It's important that teams use their time effectively. But by planning out what things you need to accomplish by certain dates, time pressures can be overcome and overall avoided.
In your preseason, this is the point in time where you're able to test different concepts such as drivetrains or different modular designs that would be probably used in an upcoming season. During this time, you can learn from different teams a lot of different concepts that maybe you don't know a lot about, such as linear actuation or flywheel-based shooting mechanisms. It really can range from anything that you really don't know a lot about. This can be a great way to build your skill set so that in the season you aren't rambling about trying to figure out something that you have absolutely no idea what you're working on.
But if you learn things, you can get an efficient design that you can keep improving before tournaments.
During the competition season, you have about 2 months between tournaments to pound out a robot and a notebook documenting it. With a robot, you have to make sure that you have a confined time management skills so that you can focus on getting a drivetrain to different modular systems to then continue to build your robot. This is really, really important because if you get bogged down in an idea that takes way too long and is way too complicated, if you can't stray away from that to something more simple that's actually reasonable within your time limit, then you can have a robot that isn't super efficient for a qualifier tournament that doesn't require something as complicated as a robot that can literally do everything on the field. Similar to the preseason, you went through a lot of concepts that maybe you used during the competition season depending on what the game challenge will bode. What you also have to take into account for is not all of your ideas may work out exactly perfectly the very first time, which is why it's really important to create different prototypes and test them out early on and make sure, hey, is this concept actually going to work on a robot efficiently for this season? If the answer is no, well then strip it down, make it simple,
and keep improving from what you already have.
Ideally, if you spend too little time on one idea, it may not get to its full potential. If you feel like an idea may have potential or it just needs to be worked out in a certain way, spending a little more time on that can help. But if it is something that you do know and your team knows is way too complicated and you can't figure it out before your next tournament, do go for something more simple, something more realistic. And ideally, you'll figure this out early on in the planning stages of your season.
By realizing that, then you can move on and work on a new idea that has better potential for success. Another point I want to strongly hit on is that everyone on the team should have at least a little bit of an experience with working on the robot, getting their hands dirty and being able to be a part of that. I joined robotics for the main purpose of being able to be exposed to that, and I've benefited from it. So you really want to be sure that you're getting everyone the opportunity to work on the robot so that they can have a great experience.
Building things, testing things, getting their hands dirty.
And then they can benefit and learn from it just as much as everyone else.
Testing is a very important phase of your robot's design. If you don't properly test, things can fail during a very, very important time in your season, such as the last 2 weeks where you're fine-tuning everything ideally. If something starts failing then, well, it's probably because you probably didn't properly test it. To add on to that, it's really important to test your ideas out and make sure that they do work exactly what they have to do. And if there are problems, address them as fast as you possibly can, because running with a subsystem that does have problems that you do know of, and you're making new changes based on those problems, most likely the other changes that were not related to your original problem will cause more problems, because that's FTC in a nutshell. Ideally, your notebook should reflect all the testing that you have done. While doing this, take a lot of photos. Videos maybe, so you can take screenshots afterwards of different phases during your testing to show the judges, hey, we tried this and it failed. Or else we tried this after 3 times and we finally found a solution that worked efficiently within the time frame for this tournament. Leaving time for the programmer. This is very important. You have to leave enough time for your programmer to program your robot and make sure that its autons, its driver control, the teleop programs are all set and ready to go.
Effectively leaving time for the programmers to design the robot will efficiently give them enough time so that they can test code and make sure that it is reliable so that it works on the competition day and has all of its flaws and kinks worked out before the competition day.
Drive practice. The importance of this is that you need to have time to properly prepare yourselves for driving your robot. Nobody else is driving your robot, so it's all up to you. In this situation, you want to leave about 2 to maybe 3 weeks with a robot that is ready to go for your tournament to properly test it, drive it, And in these conditions, you can see what your final robot will look like while it's on the field, and you'll see if there are any problems or things you need to solve while you're practicing in this situation. In the last 3 weeks or 2 weeks, when you're doing drive practice, get as much as you possibly can in until you feel comfortable. And when you do feel comfortable, practice even more. What our team will do is we'll play very, very loud music as we drive a robot. We ask them to pressure us as much as they possibly can, and we drive under the calmest conditions possible. We want to prepare for the worst. To recreate a tournament scene.
Managing your engineering notebook. It is crucial that you record and document your season in the engineering notebook, as we all know. The engineering notebook should be a top priority because it should reflect your team and your entire journey. One thing I think many teams have in common is the struggle to keep on top of your notebook and not getting behind in entries. Getting behind in entries really pulls teams down, and then it's harder to catch up and do those entries when it isn't fresh in your mind. So the concerns for the notebook can be about format and content, but teams should really be aware of the dangers of getting behind. Let's take a look. First off, there's the business and strategic plan sections. These can both be done before kickoff and before the real season begins. This should be something that gets done right away because it isn't bound to anything, but more so a task that needs to be completed. You can manage this effectively by making sure it gets done before the chaos of the build season and competition seasons. Next, the team section. This can also be done beforehand because it isn't bound to the season timeline. It can be completed in the off-season. You can assign this section to team members individually to have them fill out their own area and get it completed. Next, the outreach section. These entries should be done within a week of the event, so details are thorough and well put together. A quick reminder, make sure you have lots and lots of photos to remind yourself how the event went and what happened. As far as dividing up the workload for these entries, whoever went, found, or initiated the event should be the one to document it. This gives the entry a very natural flow and organic documentation because it is done by somebody who had the experience. Finally, the engineering section. This section is mainly the broad overview of all the entries pertaining to the robot side of things, so programming, CAD, 3D printing, strategy, building, and subsystems. The main thing to keep in mind for effectively managing is to assign the entries to people who did them. Dividing up the work is a very real thing, but the expert in each area should be doing the entry because they have the most knowledge, so they can do the most in-depth entry, making it organic with the information. I would recommend doing entries in pairs as well, so one person could do the entry and the other person could go back and add anything that could be missing. To keep up with this section, take photos. After you take photos of the robot, take 10 more. There's no cons to having too many photos because there are always a great resource to go off of. Robot design entries should be done within at most 2 weeks of when it happened. Any later, and information gets shuffled around and the timeline isn't as specific once it's documented in the notebook. A strategy to keep up with managing your notebook robot entries is taking a lot of notes during the building process, so you have your thought process down. I'm not saying write paragraphs on what happened for those of you who don't like to document while you build, but just write down a couple bullet points of what happened, so you have something more than just your memory to go off of for that entry you will end up writing at some later date. Another strategy for getting your entries done for the robot is having a team member with you while you build, taking notes. If the builders talk out loud about what they are doing, then the team member can take notes of what you're saying and possibly ask questions to gather more information. After the meeting, you can go back and look at those notes your team member wrote and create an entry off of those while also adding things from your memory. Last but not least, we have some tips and tricks for FTC, including social media presence, being prepared for the unexpected, team branding, and making connections. Social media presence is a really important part of your team identity and a way to share your experiences and what's going on with the people around you. For your social media, you want to have some sort of social media so you can stay in contact with other teams. So you can post your successes on social media. Also, having social media will make you more known in the FTC world. Also, if you have one, make sure you keep updated so people that are following you can keep up with you guys and know what's going on. This is also a very easy way to meet new teams and make new connections. You can also post some fun things on your social media, like random pictures or random things going on, but also something unique for our team is we post a lot of videos of things that we create. We're all on our team really passionate about video creation, so here's a couple of videos our team has made for the past couple years.
A person who thinks all the time has nothing to think about except thoughts. So, he loses touch with reality and lives in a world of illusions. By thoughts, I mean specifically chatter in the skull, perpetual and compulsive repetition of words, of reckoning and calculating. I'm not saying that thinking is bad. Like everything else, is useful in moderation. A good servant, but a bad master. And all so-called civilized peoples have increasingly become crazy and self-destructive because through excessive thinking they have lost touch with reality. That's to say, we confuse science with the real world.
Some say life is a journey filled with choices. One choice I made was joining First, and wow, how I've changed. You may be wondering, how has First changed me? Well, through my experience in First, I have learned to take on challenges, to work with others, and I've become a leader. A lot of people, when they first hear about First, think of robots that complete challenges. But I have a bigger story to tell. Through my experiences in First, I have become a programmer, a mathematician, an engineer, and most importantly, a leader. But the best news is, First hasn't just changed me. First is changing the world. I've made my choice. Now it's time to make yours. Choose First. Every student participated in First, we'd still have poverty and hunger and injustice. But we'd find a way to fix it.
How would the world be different?
Imagine a world
where problems become opportunities for us to come together. Imagine a world
where unity is our greatest strength.
A world where youth can reach their full potential. A world where everyone is included. Together we're louder, together we're stronger, and together we're brighter. Doesn't that sound nice?
montage of some of the videos that our team is really proud of. Now moving on to being prepared for the unexpected. There's 4 categories I'm going to talk about really quickly. For the first one, judging. You want to make sure you have multiple coaches and outside spectators to do practice judging. This way your team can have multiple repetitions of trying or being exposed to different things or different curveballs you might not have practiced or prepared for in the first place. You also want to practice every possible question. Example, our FOL days. In FOL, we practice every single question or every single part that might come up during our judging, so we were prepared for everything. This allowed us to be ready for our judging at tournaments, and we were able to be very successful through this process. Also, for the notebook, at least one person should know your notebook front to back. Trust us, it'll come in handy. On our team, I was the dedicated person who had the notebook memorized front to back. And I don't mean literally memorized, but at least familiar with what you're talking about, the flow of your notebook. So then if a judge comes up and asks you a question, you're able to elaborate on anything, have stored knowledge in your brain, so you're ready to word vomit for whatever they want. Also, for your robot matches, you want to bring every tool and part you might need along with extras. You never know when you will encounter an issue or a pit neighbor might encounter an issue. So just bringing everything that you might need, from duct tape, which we know we all need, or zip ties, or extra pieces, or mechanics, or batteries, or whatever it is that you need, so you're being prepared for the unexpected. Also, floor dances, something that we're very passionate about. You should know these floor dances before your state or qualifiers, the YMCA, Cupid Shuffle, Macarena, Electric Slide, Cotton Eye Joe, because this is crucial to your success, considering it's team spirit, making connections, having fun, and just making as many memories as you can. So why not just learn the floor dances? So if you haven't gone on YouTube already and watched them, watch the YouTube videos, learn the dances, be prepared. Team branding is another way that you can make your team stand out or prepare yourselves for the team season. For team branding, it is very important. This is the way that people are going to recognize you at tournaments. This is the identity that you're going to be building on for multiple years or be creating for yourselves. Some important things for team branding are your colors. Our team is neon green and blue, and as you can see, everything is branded with those colors. Our entire presentation is that neon green and that blue. In the picture, our robot is that color, and our logo is that color, and our t-shirts, and basically everything that can be branded is branded. This way, we're able to be recognized easily, and our identity can be recognized, and that's kind of important. You also want to have business cards on hand that you can give to people so that they can contact you and just be able to efficiently hand out a piece of you to every single person, I suppose. You also want to have a web page that you can have set up for people to find you and research you and find contact information if they want to learn more about you or as a resource to learn more about first. And also for your team branding, your team look. In Minnesota, we have a lot of different creative approaches on this. The Titanium Allies literally have like cape jackets, and there's lots of people that have sparkly hats or like different random things going on. For a long time, our look was we had khaki pants and polo shirts and light up shoes, and that was our team look. And this is another part of your identity that's kind of fun to build on, especially during your rookie year. Another thing is making friends and connections. This is a very important part for your team to be actively working on throughout your season. You always want to be looking for local businesses, for sponsorships and demo opportunities. You never know when you're going to run into somebody that's a professional undercover in like normal outfit or something, and you want to be actively looking for those opportunities. You want to be making friends and connections with other teams, so maybe they can mentor you and help you out, or maybe they're the opportunity for you to mentor them. You also want to be making connections with different volunteers, so if you ever host an event, you can invite them to come help out. You also, us, like we want to make friends and new connections with you guys too, and we're always open to mentoring or meeting up or working together in collaborations. Anytime. As you can see, here's our contact information, our website, and email, and Twitter. We also have an Instagram. Feel free to DM us or email us whenever. We're always open to meeting new people and making new connections and exploring that too. So that concludes our presentation. We hope this was helpful for you guys. If you have any other questions or anything that you want to know more about, feel free to look on our website, email us, DM us on Twitter or Instagram. We're always online or always open to hear from you guys. So reach out to us when you're ready. Thanks so much. Bye-bye.
Thank you again, Team 12528 NextGen, for a great presentation on effectively managing your FTC season. If anyone has any questions or comments for Team 12528, please post them in the live chat. You can also contact them offline at any of these channels. Our next topic is going to be on FTC robot systems and programming/season design. We will now start at the top of the hour. Oh, because the schedule changed for break, we will be starting at 4:30 p.m. EDT. Welcome back, everyone. I hope you all enjoyed that last presentation and took away some useful information and tips that was presented by 12528 NextGen from Minnesota. Our next topic is FTC Robot Systems in Design Cycle by 12808 Revamped Robotics. And as always, feel free to be putting your questions in the chat. And now I'll turn it over to Revamped. Hey guys, welcome back to the next section of the WorldShop International FTC Conference presented by RevAmped Robotics. And right now we'll be covering the four primary systems, FTC systems of a robot, and then transition into a season/programming design cycle. So here's a little bit about us. So we are Team 12808 Revamped Robotics, a third-year team, part of a nonprofit organization called Spark Technology Education. In the 2017 Relic Recovery season and the 2018 Rover Ruckus seasons, we advanced to the World Championship, becoming division semifinalists each year. And my name is Shrey Goyle, and I'm the engineering notebook lead on Revamped. This is my second year on Revamped and an FTC, but overall I have participated in first programs for 8 years. And I'll hand over the mic to John so he can introduce himself.
Hey guys, my name is John Wang, and I'll be presenting the later part of our presentation on programming design. But just a little bit about myself. I'm the team captain for 12808 Revamped Robotics this year, and I've been the lead programmer for the past 3 years of Revamped.
Thank you, John. And for the first part of the presentation, we'll be talking about the four primary systems of an FTC robot and how each of them allows you to essentially play the game. So there are four primary systems of the robot: the drivetrain, the intake, the deposition system, and the endgame system. And each of the mechanisms that are responsible for completing certain parts of the game are very important, and they follow a similar pattern. First, you use your drivetrain and intake to get to the scoring element and bring it to your scoring area. So an example for this year's challenge would be to bring the stone from the depot or the quarry area to your build site and onto your foundation. Then you would use your deposition system to put the elements onto the scoring area. So there are various deposition systems this year we've seen, and you take your element, the stone, and place it onto the foundation, and then keep building up your skyscraper. And finally, when those 30 seconds, the last 30 seconds of the match or the last 15 seconds of the match, you would start your end game where you would place your capstone, pull out the foundation, and finally park. So now let's go more depth into each of these four systems. So first are drivetrains. A drivetrain is a robot's most important part, as it allows the robot to move about the field in order to complete the game tasks. So the drivetrain must also be sturdy and robust to allow your robot to stay functional throughout the rigors of the competition. It should protect exposed parts such as chains and wheels and provide a mounting point for other robot components. For example, while you're playing a match, you really don't want your chain or your wheel to fall off, which can potentially disturb your driving, leading you to, in the end, maybe lose the match. And later on, for qualification and eventually elimination matches, losing one match can cause you to drop your ranking, causing you to not become in a picking or being chosen position. So now we're going to be talking about the common types of drivetrains. But before we do that, there's one tip that I want to throw out there for all drivetrains, is that to build your drivetrain in a flexible manner, such that you can twist it a little bit. And what I mean by this is that when you originally construct your drivetrain, pick it up in your hands from each side, and then physically try to bend the drivetrain back and forth a little bit. And this is especially important if you want all four wheels of your robot, and drivetrains with four wheels obviously, to touch the ground. If you have a rigid base at the start when you build your robot, when there is no weight, you may have problems regarding balance because not all of the wheels of your robot are contacting the ground. The addition of weight on your robot over time will allow it to naturally take shape and ensure all the wheels are firm on the tiles. So let's jump right into the types of drivetrains along with their pros and cons, and when to use one type over the other. The first type of drivetrain is a mechanism drivetrain. These are very common as they are easy to build and can provide a team with much maneuverability. However, because the maneuverability comes from the independent rollers on each wheel that aren't powered by a motor, you can be very easily pushed around. Personally, this has been our go-to drivetrain this year and in the relic recovery season. Next is the tank slash six-wheel drivetrain. These have 6 or 4 wheels, and like mechanism drives, they're simple to build, but unlike mechanism drivetrains, they have low maneuverability because the type of wheel that's used on this drivetrain is not those mechanism wheels with the rollers. They're just standard. They're just standard wheels because and this does not give you that strafing capability. But there is one way to combat the issue of maneuverability in some sort of fashion, which it is it's termed a drop center drivetrain. Um, and basically, it's what the name says. You drop the center wheel on the drivetrain on each side slightly to assist in turning. And these are really good for defense because, like I said, the wheels aren't those wheels with the independent rollers, so you have good grip. The next drivetrain is a omni-wheel drivetrain, or a holonomic drivetrain that can provide true omnidirectional movement, such as moving in circles. These come with low maintenance, but they have many cons, such as they have less grip on the field because they have those small rollers, making them easier to push. They're also slower in all directions, and the angles of the wheels must be really precise. If the wheels are off slightly, that'll cause your driving to become really whack. And also with these omni wheel drivetrains, it's really hard to climb objects, as is the case with many seasons, such as in Relic Recovery. You need to climb the balancing stone, or in the Rover Ruckus game, if you choose to climb over the foundation or climb over the crater wall. And the last type of drivetrain we're going to be talking about is the swerve drive. This drivetrain is kind of the best of both worlds. It has grip for defense, and it's also really maneuverable. However, the cons are very weighted. It's complex to build with very high maintenance. You need to be constantly checking the motors and the servos and the chains. And not only does this consume 4 motors, it also consumes 4 servos to rotate each independent swerve pod. And this drivetrain is also really heavy because of those really big swerve pods that you need to have. So now, once you have your game element that you use your drivetrain to get to, you need to have some way to actually score it, which is the majority of the teleoperated period. And that's what we'll be covering now. So starting off with intakes, there are basically 2 types of intakes, active and passive. 100% of the time, you want to use passive intakes over active ones because they do not require precise driver operation to use. For large game elements, it may come quick to mind to immediately jump to an active intake, but remember that you can still use passive intakes with them by using compliant wheels, as many teams are doing this season with the green or gray compliant wheels of different compliancy. And now let's get into some examples of these active and passive intakes. On the left is an active intake. It's basically a claw, and on the right are passive intakes. So, like I said, great examples of active intakes are claws that require drivers to precisely align against game elements such as a stone and then pick up, or passive intakes where you can kind of go in that general direction of the stone or the game element, and it'll with a little bit of driver operation, that game element will come into your robot. So here on the right 2 pictures, you can see a noodled intake and a compliant wheel intake. The compliant wheel intakes are really good for larger game elements, while the noodle intakes are good for smaller game elements. Once the game element is collected, there must be some way for it to reach the scoring area, known as the deposition system. And one tip is to reduce the number of times the game element is moved in your robot. And what I mean by this is that you have to reduce the number of times it goes from your intake, then to another holding area, then to another holding area, and then finally to the scoring place. So in our Rover Ruckus robot, once we got the minerals from our intake, it would go to a holding area at the base of our robot in which they would be popped up a set of popper tubes, which are these things right here. And then they would be stored at the very top in another holding compartment to be finally deposited into the lander. And like I said, reducing the number of transitions these minerals go through or these game elements go through increases your efficiency and speed, which is very key to scoring more cycles. And finally, the endgame system. And in the endgame period, you would obviously use your endgame system to complete the endgame task to score those extra points. And the task usually requires linear motion, such as latching onto the lander in the Rover Ruckus season, or extending to the top of your skyscraper to place your capstone. This is an example of our Rover Ruckus endgame system. It's a passive latch mechanism that allows us to just align underneath, contact the lander, extend it up, and then we can latch onto the lander. Usually, throughout all of these endgame tasks in the seasons, they require some sort of linear motion. And this is best seen, you have to go in previous seasons, like Relic Recovery, you have to extend outside the field walls to place down the relic on the relic mats, or last season where you had to extend a little bit up to grab onto the foundation or the lander latches, or this season where you have to extend to the top of your skyscraper to cap your tower. So that wraps up the 4 systems of an FTC robot, and now we'll get into some programming and season design. So this is your general design cycle that can structure your season. So first, if your team participates in league meets, which is a very good idea, then this is a general outline that you can use to guide your team by setting goals that can be accomplished in reasonable timeframes. So from kickoff to League Meet 0, you'll want to have your ideas down, pick one, and construct your drivetrain to bring to your 0th League Meet. And this 0th League Meet is usually treated as a scrimmage. During the weeks between the following League Meets, so 1, 2, and 3, you should begin to make changes to your robot, ideally increasing your scoring potential each meet. After the meets are over, you'll need to begin working both on your judging and your engineering notebook because this is your first judge competition. And remember, your robot is not everything. Even if your robot fails on the competition day, a strong judging session and a strong engineering notebook is just enough, will be plenty to propel your team forward to the next stage of competition. If you advance from the league championship to the super qualifiers, your judging routine should be fine-tuned along with your robot. And then this cycle kind of continues of fine-tuning and judging and engineering notebook continues all the way up to the world championship if your team makes it there. But one important point to note is that from the time frame of your state championship to the world championship, no major design changes should be made. There should be the removal of no new parts should be added, or no big systems should be redone. They can only be optimized for efficiency. So now we're going to be looking in some considerations that you should have in the initial stages of design. First is scoring location. And the main question to ask here is where are the scoring objectives located in relation to the scoring areas? So for example, where would the stone or the depot be located on the field in relation to the foundation, and what's the driving path you need to take to get there? Next is the scoring objective, and how will you efficiently play the game while completing your objective to your robot's best ability. Finally, and it can be argued as the most important one, is field arrangement. So where are your choke points, and where are robots most likely to be, and how does your team plan to play offensively and defensively to make this driving more efficient? So now let's look to some constitutions of an effective design. First is scoring under competition conditions. How much you score in a correct field, meaning the right number of game elements, or the presence of other robots, changes if you do not have these things met. And from our own personal experiences, we really had, you can say, quote unquote incorrect fields while we were practicing for our league meets. And we quickly realized this, and we created what we called better driver practice to give the drivers more adaptability while driving. Next is a robot's reliability and simplicity. Simple robots are often more reliable due to quote unquote less moving parts. And simple robots make it easier to maintain and fix problems. And in the end, simple robots are generally likely to be picked because they're more reliable.
All right, thanks, Shrey. In addition to talking about the FTC robot systems and mechanical design, we thought it would be a good overview to share a bit on how we manage our programming time between research, developing, and testing our programs and algorithms, and some of the lessons that we've learned along the way. So this is just going to be a quick summary. I'll go into a little detail, but I won't stay on one subject too long. So let's get started. As always, feel free to keep track of questions if you have any for question time at the end of the presentation. So just starting with the basics. I think we can all agree that FTC programming has definitely evolved throughout the past few years, and the level of programming that I've seen since I joined to now has definitely progressed a lot. And with that, we've also seen a large growth of online resources for FTC programming. But even so, I think that the basic aspects and goals of programming have not changed. So in every programming foundation and in every FTC challenge, we require a reliable vision recognition system, a consistent driving method, and a consistent turning method. So these are kind of the three big tasks that will never change in an FTC season. So along with this, there are some questions that we have to ask for each task. The first of this is, what is our end goal for this task? So what specifically do you want to accomplish with this? For vision recognition this year, it could be being able to detect the sky stones from against the wall where you start at the start of autonomous, or being able to detect the sky stones in less than a certain time threshold, like 1 second or 2 second. Um, and then the second question that we should ask is, what do we need to complete this task? So more specifically, what resources are you going to need to complete this program? This might be like a mechanical enhancement or a hardware component that allows your camera to be in some orientation on the robot so that you can detect the sky stones, or whatever it may be. What do we need to complete this task? And the third question that you have to ask is this task feasible? Or do we have the experience and the resources to complete this with consistency and reliability? If not, then it's worth looking into other solutions. And then just at the end of the presentation, we'll go over some cool stuff and some maybe extra stuff if you're done with the basic tasks in every FTC control system. So I'll just start by showing a little bit of examples on end goals. These are just certain examples of a good auto and a good teleop for this year. Obviously, this is not the only definition or the only example of a good robot or a good program. And in fact, many teams only do quote unquote the basic auto or the basic teleop in endgame. But if this is done consistently, it's certainly much better than a robot that can complete maybe 3 or 4 stones in autonomous but doesn't do it consistently. So let's get into what constitutes an effective program. So starting with autonomous on the left, these are just some criteria to keep in mind that we found to be an increasing priority through just experience and years of testing. So the most important aspect of a programming system is to create something that has consistency. In our experience, this means encompassing a program that is closed loop. So this means some sort of sensor feedback that can always correct error if needed. An example of this could be driving to a certain position or a certain distance. And while you might use your motor encoders as the primary sensor feedback, adding something like a distance sensor or some other backup to ensure that your first sensor reading is correct is something that will help catch error and help increase consistency in your program. The next criteria to consider is compatibility. And especially with this year's challenge, compatibility should be a key design consideration for when you're programming. I think this is one of the first years or the first year that specific auto paths haven't really been coordinated between teams or agreed upon between teams. So it's especially important this year that in autonomous you have as many paths as possible so that you'll have a compatible path no matter what alliance partner you're paired with. And this actually has a really big impact with alliance selection and picking alliance teams. And we've seen in our season this year teams that have been doing great in qualifications, but they just can't be compatible with our robot. And because of that, we're not able to pick them or they're not able to pick us. So a team that has as many compatible paths as possible is definitely more likely to be picked. Third, and you'll notice that this is the third consideration in terms of priority, is high scoring potential. So in this year, that would be how many more Skystones can you deliver across the sky bridge, or how many Skystones can you place onto the foundation. And I cannot stress enough how much of a priority this is lower than consistency. So you always want consistency before high scoring potential. And as I mentioned in the previous slide, a robot that can do the basic tasks consistently is so much better than a robot that can maybe do more stones in autonomous but can't do it reliably. So something to consider when you're going for high scoring potential is how many, or in the case of this year's challenge, how many sky stones can I deliver across, or how many stones can I deliver across while ensuring that I already have the stones delivered across that I have now. So it's basically adding stones and making sure that what you have now is still there. And then a last consideration to take in mind when programming in autonomous is efficient path planning. So we only have 30 seconds in auto, and because there's no cap this year in autonomous, it's always worth it to spend close to or all 30 seconds trying to score as many points as possible. And as you get close to the 30-second limit, start looking into ways that you can be more efficient with your path planning, be more efficient in how you're grabbing and delivering stones across the sky bridge. So on the teleop side, there are also some considerations to take in when programming. Our team included, I feel like many teams don't really emphasize the teleop side of programming as much as autonomous, but there are still some things to keep in mind. So in our experience, the most important thing is driver satisfaction. So as long as the drivers have what they need and have what they want, the rest is up to them to maximize the robot performance and utilize what they have. But programming has to make sure that they have exactly what they want and exactly what they need. In our experience, this includes realistic moving, so translating maybe joystick values for motor powers and scaling it in such a way that that fits the driver's tendencies, so that the robot moves in a way that it expects it to. Another way to do this is through sensors and feedback. So using things like LED panels or like the Rev LEDs to display certain robot statuses can really help drivers and give them like an indicator of what the robot is doing. Um, Using sensors like limit switches are a really good way to control slide movement and take ease off maybe the concern that slide motors will stall when you have like automatic boundaries for slide control. And then going further into like teleop advanced programming, doing automation in certain teleop tasks. This year, an example would be like automating some sort of stacking or some sort of grabbing the stone, or even having an algorithm to just detect where the skyscraper is and help the robot align. Uh, Things like this are maybe some things to look into. So let's get into the timeline for the programming process. The bulk of your time and also the most important part for development is the summer. So it's extremely important to use all the time and take advantage of the summer. And while kickoff might not be until September, this time is your time to research new programming tools and work on perfecting or creating the methods that you know you will need for the upcoming season. So going back to our big three tasks, driving, turning, and vision, this is the time to start working and develop better methods for each of those. While vision might be harder to do because you don't know the game element you want to detect yet, maybe looking into previous year's challenges and seeing how you can optimize vision in those scenarios can help you in the upcoming season. As we've seen, game elements that we currently have to detect are pretty similar through each year. Like last year it was the yellow minerals, and this year it's the sky stones. But definitely turning and driving are things that you can focus on during the summer because you know you'll need it every year. And this is also the time to explore and experiment. So in terms of driving, do you want to stick with just the motor encoders for driving a certain distance, or do you want to try using external encoders? In terms of turning, one question to ask might be to experiment with both the Rev IMU inside the hub or external IMUs like the NavX gyro. So once the season starts, you generally have a 1 to 2 month buffer before the competition begins. So I'll just be referring to our competition timeline that Shrey mentioned earlier, which constitutes of 4 league meets, a league championship, a super qualifier, the state tournament, and then the world championships. As I said before, we have about a 2 month buffer between kickoff and the start of leagues. So during this time, it's really important that you make sure your major programming projects are completed, as it's really hard to start or work on big projects during the league meets. We found that league quals the league meets are a really good time for testing and refinement because it gives you a chance to use your programs in a real game scenario while they don't really count towards advancement. So especially the really important thing to do during this time is to see how your program works in a real game environment and to collect a lot of raw data and do a lot of analysis on how your program is doing and to respond in the correct way to make your program better. So outlined below are several ways that we do this by evaluating in-game performance. One thing that we always do is have a post-mortem or retrospective after every tournament or meet, just to go over what went well with the program, what needs to be improved with the program, and what's promising with the program. And this can also help us find unforeseen challenges during the game, as well as resources that you might need to complete your program, like a hardware component. Um, so another thing during this time is that you can still work on minor projects that might be incorporated later into the season. But one thing to keep in mind is to do this on a separate branch if you're using GitHub, and make sure that your main code is still intact. So in addition to developing a program, testing and debugging is just as time consuming, if not more. That's why it's extremely important to have a good version control system and good programming and testing practices. One example of this is using code freezes. So a good habit is to stop making new code or writing new code about 3 to 7 days before your competition. This gives you ample time to find bugs and to test your code to make sure that it's ready for the game. Another thing to do is code reviews, preferably every week, but definitely before and after every competition. So just getting your whole programming team together and looking at the code that you've been doing to try to get more eyes in the code and see if you can find any bugs or any potential problems with your program. And as I said, do this before and after every competition. And then in terms of version control, when you're doing development on separate tasks, such as if you're looking into using a webcam and doing odometry at the same time, you want to do that on separate branches so that they don't conflict with each other. And then the most important thing with version control during the season is to have a working version at all times. There's always uncertainty with testing new things, but keeping a working version will make sure that you can always revert back to what you had before in case you can't apply the changes that you've made for the next competition. So in terms of testing and debugging, there's some things to keep in mind. Ideally, when you're doing testing and development, you want to keep the component on a test bed and not on the robot at first. So an example of this is that we first tested the webcam on actually just a Mechanim drivetrain and a test bed rather than the actual robot. And a reason that you want to do this is so that you don't have some unexpected program behavior that may mess up other components of your robot the first time you're testing it. And then a similar practice on the software side is to create separate tester programs for each component or each method that you're developing. This just makes sure that you don't mess with what you already have and what's already working. So once you're actually doing the testing, it's really important to have a way to log or collect raw data for each test. This allows you to review and analyze your data after testing. And there's two primary ways to do this. One is through telemetry and one is through logs. Logs are really useful as you can pull them down after every test and then you can further analyze them through different tools, Excel and spreadsheet. You can make graphs and analyze how your program is working and see if it's behaving as if you want it to. So this next slide is just going over some cool programs that I've encountered and I've seen over the past few years. By all means, this is not something to just jump into, and this is definitely something to look into over the summer. As the first point suggests, this is beyond the basic autonomous. So these are just some considerations that you might have for the next season or trying to take your programming up to the next level. The first point is faster image processing, and vision recognition. So in our experience, at least, the FTC provided vision software hasn't really been adequate for our needs in terms of the time it takes to detect and how close you have to be to the target to detect it. We found that it's been worthwhile to develop our own image processing program to achieve things like detecting the sky stones in less than half a second and being able to do so before the autonomous period even begins and being able to do it while next to the wall. So this is something that you would do during the summer. Another thing that I've seen become more and more popular is location tracking and movement. So basically the utilization of non-motor encoder systems, odometry systems to track your X, Y, and Z position at all times, where Z is your theta or your heading. And then some considerations to keep in mind is whether you want to use absolute or incremental encoders. Most teams use incremental, but there are definitely some teams that use absolute encoders. Another thing is to see if you can take full advantage of your IMU. So an example of this is actually during the relic recovery season a few years ago, where we had an automated balancing program to get onto the balancing stone, and this utilized all 9 degrees of freedom of our IMU rather than just the heading orientation. And then finally, looking at libraries like Roadrunner and other path planning resources, I know has been extremely popular and successful for many FTC teams. On the aspect of driver enhancement, one thing that's pretty cool is field-centric driving. So being able to move your robot relative to your position at all times, basically taking in your heading at all times and then transforming it back to a global reference frame. These programs definitely take a lot more math, a lot more research, but if they work, it's pretty cool to see in the actual match. So I'll just leave you guys with some final thoughts. I know I've said a lot, but I really want to just say don't be too stressed with programming. In my experience, I've had a lot of times where I've hit roadblocks and it felt like there's no way to get past this, but it's been a learning process and it continues to be a learning process for me and my team. And we've learned that it's so much more about the journey than about the end result. As well as we've seen, perfect programs almost never actually happen, and perfect results almost never happen. This isn't meant to discourage you, but just to show the emphasis that the journey is a lot more important than the end result. With that being said, it definitely comes with many, many hours of programming and testing your algorithm or your program to make sure that it works. But it definitely helps to look at online resources like FTC Forum, the FTC Discord, FTC Reddit, as there's a lot of resources that are already there to help you. And there's definitely great users online that are really willing to help you. And in my personal experience, there's been many teams and many friends from other teams that have helped me save countless hours during development and testing. Final point I want to address is the importance of mentors. Obviously, you don't want to have them code for you, but oftentimes they can help you guide you in the right direction and give you pointers when you feel stuck. Yeah, and of course there's a lot more to be said, but this was just a brief overview of our programming process and timeline, as well as some of the lessons that we've learned along the way. And I hope this has been helpful for you guys. Yeah, so I hope this has been helpful for you guys. And if you've had any questions during Shrey's presentation or mine, please feel free to ask away now. Thank you all for your time. Thank you for tuning in. And now we'll go into some time for questions. Yeah.
Thank you again, Team 12808 Revamped Robotics, for a great presentation on the robot systems of FTC and design cycle of programming and season. Now, if anyone has any questions or comments for Team 12808, please post them in the live chat. You can also contact them offline on any of these channels. Our last session is going to be on outreach, and we will be starting at 5:30 p.m. EDT. Welcome back, everyone, to the last presentation of the day. I hope you have all been taking away some useful tips and tricks from all of the presenting teams. But last but not least, in the presenting slot, we have Team 7593 Tigerbots presenting on outreach. I'll hand it over to them.
Hello, welcome to the outreach presentation. So to start off, today's presentation is basically going to be a presentation for both beginners to outreach or people who have been doing outreach forever. This is something that's really important, I think. And yeah, so before we get started, we're going to tell you a little bit about us. So, hi, my name is Jade, and I am from FTC team number 7593, the Tigerbots. We are from Belmont, California, so we're in the NorCal region, located at the edge of the Silicon Valley. We are an all-girls team, and we've been around since 2013. We have won the Connect Award, both at the regional level, and we got second place Connect back when Super Regionals was a thing during, when was the last year that we had Super Regionals? 2018. And fun fact, we actually completely advanced based off of outreach back in 2018 in the 2018 Worlds for Relic Recovery. So yeah, pretty cool stuff. That's why today we'll be talking about outreach. There is a pretty funky picture of us too, because we like to think that we're weird, but that's cool. So, to start off with, what is outreach? So, outreach, as we like to describe it, it's basically community service for STEM or for robotics. Of course, it's much more than that, and the real main part of it is connecting to people outside of your team, but it's really about getting involved in your community, both your, I guess we call it community outreach, even though we call it community service, but both your kind of local community and also the business world. It's also really about spreading the love of STEM and learning how to be leaders with both outside of just your team. So why do you do outreach? Obviously, there is the obvious answer at the bottom, which is it can help you in awards, but it's really more than that, or at least that's what we like to think. Outreach is a really core part of our team because it's something that we think is really important because, well, we think building the robot's really important. Showing our love of STEM and getting more people involved is something that is just as important because it helps with sustainability and making sure that there are future generations who are passionate about robotics. So, other reasons why you should do outreach is it supports gracious professionalism. As Woody Flowers said, be a gracious professional. Thank you, Woody. May you rest in peace. But gracious professionalism is something that is core to FIRST, and it's something that we should all embody as teams. So, that's a really good reason. It's important to learn how to be a gracious professional just outside of competitions too, which is great. It helps you engage communities in STEM, especially communities who might not be as involved in it, which is really good because STEM is really important. It can get as an on an individual level, it can get you opportunities, which is great. I know for us, through one of our industry connections, we've been able to, one of our team members has been able to have an internship at NASA, and currently another one is applying, so that's really awesome. And we've also just been able to slowly develop more and more connections and get more opportunities for our team members because of that. And of course, it teaches you how to interact with people professionally because that's something beyond FIRST that's really important. I mean, I'm a senior right now. I know robotics really helped me with college applications on a whole nother level because of outreach. It helped me a lot with interviews and stuff like that. So, and it helps you build relationships with sponsors. So, when you do outreach, it gives sponsors another reason why they might want to sponsor you. I mean, one of the things we always highlight, I'll talk about more of this later, but we always highlight education and our passion and how we're passionate about getting girls involved in STEM, and it's something that our sponsors always find super interesting and want to support us accomplishing and want to help us that way. So there's that, and of course, as I said earlier, it can help you win awards. Not saying it always does. Of course, your robot has to work, but it is really good for helping you get the motivate, connect, I think potentially think, though I don't know if it's as necessary as much as your engineering section, and of course the Inspire Award. So examples of community outreach. So for starters, we divide our outreach into two different sections. We have community outreach, which is really reaching out to your community. I'll talk more about what we just kind of describe our communities as later on. And then we have industry outreach, which is reaching out to the business world and people who are already involved in STEM, who are either sponsors or people just we're interested talking to and learning from. So to start off with, we have the first community, so that's kind of like the internal, even more specific FTC community, and you can do outreach in there. It could be anything as simple as making Reddit posts and working in social media, though that can also go into the local community and even regional, national, and global communities. Or it could be hosting a FTC tournament, which is something that we've done, and we have qualifiers over here in NorCal. Not sure if that's okay, if that's how other teams can do, but I know there are a lot of teams who also host FLL tournaments, which is what we have also done in the past. And of course, you can help other teams by making tutorials or vlogs on YouTube. Vlogs may not be as necessarily helpful, but they help inspire other teams. I always like watching vlogs because it makes me feel really motivated to do robotics. And on the next level of our community, we have the local community. So that goes outside of FIRST, and it's where you are reaching out to your kind of like local, as I just said, obviously, to your local community. And so this can be anything from working with kids in your school to working with kids in different schools. One of the big things that we do as a team that I'll talk more about a bit later is helping Girl Scouts earn badges and teaching them and introducing all of them to STEM. And also other examples of community outreach are, I'm trying to think, on the local level. I'll think of some in a second. And finally, we have regional, national, and global communities. So that starts to get pretty big. There's some amazing, amazing things that I've seen teams do on a global level. One of our teams that is our friend, We Love Pie. I don't know their number. I'm sorry if you guys are watching this. They're actually probably at NorCal Regionals right now, so good luck. But they helped start FLL in Nepal, which is really cool, and really went there. They went there and they ran a program there, which is really cool, and helped school kids start FLL teams. And they basically expanded FLL. I know some teams have even worked with governments and worked on expanding FIRST, which is amazing. And like regionally, there's also a huge like kind of social media campaign, which also can kind of go into the FIRST community, but I know a lot of them have spread outside of that. But so I'll talk again more about examples later, but like FIRST Like a Girl and LGBTQ FIRST are two examples of campaigns. Going back to local community, more things that you can do on that level. Wow, I really can't think of anything. Okay, I can't think of anything else, but there are a ton of things that you can do on a local level, more than just going to schools and helping with Girl Scouts. Oh, you can even do things that are technically not necessarily robotics related, but like you can go help do some community service and really show that robotics teams care more than just about robotics and really want to make a positive impact on community, especially with this year's theme being about making a future like planet that's sustainable for everyone. That's something that we're really trying to do as a team. So yeah, so going into more, we have an example of one of our vlogs right here, which I will play in a second. We think vlogs are a really kind of fun way to get people engaged, and yeah, it's cool. So yeah, it's really just a fun vlog. I know a lot of teams that make actually a lot more informative vlogs, but we think it's a really good way to kind of introduce our team to people, and you can send them to sponsors, and it's a really good way to keep them updated as well. So yeah, really useful outreach. We recommend videos, but you can also post things on Instagram, Twitter, Facebook, Reddit. What else am I forgetting? Tumblr, I guess, if they're still there. TikTok. I know some teams are starting to make TikToks. Big Reddit. I'm missing like a big one. YouTube, obviously. Yeah, but there are a bunch of options on social media, and if you are allowed as a team, it's definitely a really easy way to get some outreach done, and you honestly get to see a lot of cool teams. It's because of social media that we actually get to do this WorldShop, which is really cool. Okay, that's what I was forgetting about community outreach. So on a local community, working with a lot of local teams, having scrimmages is really good. Kind of also bridging between first community and local community. And then also just working with teams internationally like WorldShop right now. Again, really great examples of outreach. Okay, so kind of going back to local community outreach and talking a bit more about Girl Scouts. So back in 2018, we decided, after Girl Scouts released 3 badges, we decided that it would be beneficial to create a curriculum that helped us teach the Girl Scouts the appropriate things to earn their badges. So basically, the badges are designed for daisies, which are I think 5 to 6-year-olds, brownies, 7 to 8-year-olds, and juniors, 9 to 10-year-olds, and have different levels of things. Obviously, there are different badges, or slightly different badges for each age group, but one of the things that Girl Scouts had that we realized really wasn't that useful was that they had a lot of words in the Brownie and Daisy guidebook, which is what they're supposed to do to get their badges. But what we realized is that 5-year-olds can't really read, so we created a curriculum that basically is a much more hands-on experience to help them get their badges, something that we do as a FTC team. And so we've been doing that a lot. I think we've reached now over 250, maybe close to 300 Girl Scouts in our area, and we're working on sharing our Girl Scout curriculum. So if anyone's interested, I'm going to have our contact information down below. But it's really fun. Education is something that's really important, and we've worked with NorCal Girl Scouts to really make this more of a possibility. And yeah. So moving up a bit to the global, national, and regional level, we have, I'll put a picture of the globe because of that, we have social media campaigns. So a bit more about all of these. First Like a Girl is a great campaign that's encouraging girls to get involved in FIRST, something that we don't see a lot of, and of course is really important to us, not only as an all-girls team, but a lot of our teammates are really passionate about getting girls involved in STEM because we are all girls involved in STEM. But we think it's something that all teams, even if you're an all boys team or all boys team, that can get involved because it's a really good message. We also have LGBTQ plus of FIRST, which they're really pushing for FIRST to be a really inclusive space, kind of similar to First Like a Girl, but also accepting of all LGBTQ plus people, and it's something that we as a team really think is important. And of course, we also have the campaign that we started, which is First for Earth. Please follow us on Instagram and Twitter at First for Earth. But we decided as a team that we wanted to connect to things that we're passionate about, so protecting the environment and robotics. So, because we think as first teams, we have a responsibility to make sure that we can be sustainable so that we can be making all of our robots and doing all that stuff in the future. So now we're moving on to industry outreach. So again, industry outreach is reaching out to more of the STEM world, so people already involved in STEM, mostly adults who are currently working in STEM, though it can also be college students who are studying engineering. So some examples are meeting people in STEM careers. This can include visiting companies, or we've had design reviews with a couple companies, including NASA, to help us actually figure out a robot and get to kind of bounce off ideas, which is really fun, and it kind of gets us into what it's like to be a robotics engineer in a lab and being a literal rocket scientist and stuff like that. And it kind of sees that we are learning, it shows you that we're learning what it takes as people involved in FIRST to work in these companies. And of course, there's also working with your sponsors. So I know not all teams are able to have sponsors due to complications, but if you do, sponsors are a really good way about industry outreach. They can be anything from presenting to about your team and your robot, to keeping them updated on progress, or giving them shop tours, or even going and visiting their facilities. We have been working with one company, Bishop Wisecarver, for the past couple of years, and we always make sure to go to their manufacturing day because it's such an informative experience, especially for our rookie members. Another and really important part of industry outreach is, like, I know some teams even try to make brand deals, which is really cool. And it's also really just exploring different opportunities in STEM, because STEM is such a wide field and there are so many opportunities, and it's really important because you're also sharing FIRST with all these places. And if the more people that know about FIRST means that they're aware of what we're doing and how prepared we are for jobs like that they're currently doing. Industry outreach is really important for the Connect Award if you're interested in that. And yeah. So at this point, you might be wondering, how can you grow your outreach? So here are kind of some steps, I guess, you can take to think about or how to kind of start growing your outreach. So the first thing that you want to do is think about what makes your team unique. So you have to kind of think about this with a business perspective, that your team is a business and you're trying to sell your product. Like, you're trying to sell your team to different, I guess, organizations or sponsors or anyone who you want to do outreach with. So you have to have a selling point. Of course, you can always do that you are a robotics team. That's something, and that you're a bunch of young adults who are trying to build robots. And honestly, if you explain first and all of that, that's something that a lot of companies are really interested in, or a lot of like schools and stuff like that, especially when you mention like FLL or FLL Junior. We also use that we're an all-girls team. Gotta take that to our advantage sometimes, because a lot of, at least in our area, a lot of companies really like that. I know it's not the same for everyone too, so obviously do what's right for your community, what you think will work well with people, and you just kind of gotta pick a point and really like advertise it and be like, hey, we are a robotics team that's really trying to educate. Would you be interested in us giving a presentation to you, or would you be interested in having us come in and show our robot and stuff like that? So the next thing that you want to do is set goals. So setting goals is not only important for you, but it's also really important for Engineering Notebook. Judges like seeing that you guys have set goals, and because it shows that you have like something that you're aiming for. It also helps you make sure that you're going into the right direction. You also want to use your network to make connections. So both for community and industry, it's really important to go through all of the connections that everyone on your team has. We go through parents, family, friends, teachers, because we are a school affiliated team, teachers, co-workers, parents, co-workers, like anyone that you can find. Our friends sometimes know people who are really interested in robotics, and honestly, like, you just have to, because you would be surprised, people know people. Sounds kind of ridiculous, it's a really awkward experience sometimes, but you can't be afraid to ask. There's a lot of connections out there. And then sometimes you do just have to be bold and ask random people. Our coach, a couple years ago, our old coach, she was out looking for a very specific part for us because we were all in class at the time. And we found one of our old sponsors that way, which was really, really funny. Because she said that we were a robotics team and they were really interested in getting back into the world of FIRST. So, and of course, the next thing is to add new sponsors. So again, I know sponsors aren't possible for everyone, but if you can, try to get new ones. New blood always helps, kind of getting those new opportunities. Working with a new sponsor who might be new to FIRST is really great, because then you get to explain all FIRST, and then you can get them involved in the FIRST community, which is something that's always really fun to do, because people get to realize just how amazing FIRST is. That's really awesome, and especially FTC. You can also present and demo at school events, because that not only do you get outreach from that, but you can also potentially start a FTC team, depending if it's a middle school FLL or FLL junior team that way, and that's always good outreach as well. Of course, there's social media, so if people see you on social media and you have a good account that's active, you want to make sure that your social media is active, of course, though. Try to post pretty regularly. But if people see that, then they might be, oh, wow, they're really active robotics team, I want to work with them. And of course, you got to be creative. Gotta learn how to think outside the box. I've been doing robotics for 4 years now. I think I said earlier I'm a senior, but if not, I am. And honestly, at this point, I'll be trying to fall asleep and I just think of a new outreach idea. So I know, of course, that's not everyone, but you kind of just have to get into that mindset and always be thinking about, where can I get these opportunities from? And of course, last but, oh wait, I already said be creative. But you really just got to think about any single opportunity, like, be bold. Yeah. So tips for reaching out, because I know that's always a difficult process. The first thing is be professional. So I know that's kind of broad, and everyone has different definitions about being professional, but you have to make sure that you're really polite. You have to, if you're meeting someone who's a sponsor, make sure that you're dressed somewhat formally, or like you're wearing your team uniform. And you want to be very attentive. Firm handshakes are always good. And of course, there comes the next tip, be clear about what you want. So I know sometimes, especially when you're asking for money, potentially, it's really hard to kind of just straight up ask, but sometimes that's what you have to do. Of course, you want to fluff it up a tiny bit. You want to kind of introduce your team, explain always what you want the money for. You can't just say, I'm a robotics team and I need money. You have to explain like where that money goes to. But sometimes companies only want to give you specific funds. So explain that you need it for tools, different parts, travel, outreach and business materials. Because I know we spend a lot of money on stickers. Not a lot, but we do have a small budget for stickers. And you want to be really just upfront, and then also explain how much money it takes to run a team, because it's not cheap, unfortunately. First should be accessible. And of course, you have to be really good at following up and following through. If you promise a sponsor or any or like a school something, you got to make sure that you can do it. Even if it's a really busy time, if you made that commitment, you have to follow through, because then you might lose a really valuable outreach opportunity, and then you might even lose like future opportunities, because they might think in the future that you're not a reliable team. Also, finally, First has a ton of resources available. Use them. By using the resources through First, I know we've got sponsors that way. They have examples of engineering notebooks. You really have to reach out, look through them, and kind of figure out what things they have there. And of course, also reach out to other teams. You don't have to be necessarily as formal, but they can always give you advice about that, or they might have outreach opportunities. Of course, reaching out to other teams even counts as outreach. So again, make sure to be professional when reaching out to other teams, but you don't have to be as formal. Be a bit more chill. And again, as kind of sound like, these tips are also really important for getting sponsors. So definitely follow through. Also, another thing that I just thought of, write thank you notes. I know some sponsors request it, but thank you notes, they really make the difference sometimes, and they show people how thankful you are for like their help. Of course, if you're doing something for a school, it doesn't have to be as formal, but if you're doing any industry outreach, thank you notes, they're wonderful. Our team printed a ton of custom thank you notes for our team, but of course they don't have to be. You can literally just use printer paper and get some fun highlighters and decorate them, and get some stickers, because stickers are always fun too. Apologies. Yeah, so here comes the important part, going kind of back to awards. Don't forget to documentation, engineering notebook. I know, as the business and marketing lead who has been in charge of engineering notebook in past, it's something that's always hard to do, even if you're the one in charge of it. But you have to make sure to document all of the outreach that you do, or else there's not really as much of a, it's not that there's not a point, because of course you're helping out the community and learning more about industries and learning more about learning more about your community even, but of course part of this is about getting awards. So if you really are aiming to get those awards, you have to have really good documentation, make it really clear. So you want to keep it current as possible, and you want to make sure that you can describe what you did, what you learned, which is something we always add because honestly, the most important thing that judges want to hear is about what you got and what you learned from the experience. And of course, you have your next steps. So, what things like you might want to change. So, when we hosted our FTC qualifier this year, we wrote down the things that we wanted to change next year. And also, if you want to remember to reach out to them again and all of that stuff. So, next steps. So, here we have examples of our engineering notebook. Here's a chart that we have at the front of our community outreach section because we divide it into 2 different sections, so it's really clear to judges what we're talking about. But this kind of describes our levels of outreach. So we have hyperlocal, which is our school. So we do a ton of things at our school for recruitment and sustainability because it's really important that we get new members every year to kind of fill the places of the seniors that graduated. So we go to a ton of different events. At our school, we have a welcome dinner. We have a recruitment period, open house, and of course, we do work with other students. We were currently making a panel at our school, introducing female engineers. And of course, then we also talk about our local outreach. Oh, we gave a kickoff presentation. That's also something, if you can give kickoff presentations, they're really fun to give because it's just fun. It's a good way to start off the season officially because I know the season technically ends. Oh yeah, other good point about outreach. Sorry, my brain's very chaotic. I was just thinking about this though. You can start doing outreach as soon, I think, technically after Detroit Worlds ends. So this year, that's end of April. You can start doing outreach for the next season the day after Detroit Worlds ends, and it totally counts. And it's really fun. It's a great thing to do over the summer, especially because it does count sometimes for, I know, people's community service hours, and also just keeps you active as a team, keeps you busy, because robotics is a year-round thing. So do outreach during the summer. It's fun. And of course, you have global outreach. So here's all of our campaigns and social media. Though that kind of goes into first outreach. And of course, if you're interested, you could always be starting teams in other countries or even working with stuff like that. So here are 2 examples of our engineering notebook. So here we have our First Like a Girl page, and we always make sure to highlight it and use a bunch of different colors, kind of. Normally have a bit more pictures, but First Like a Girl, we didn't have that many pictures at the point that this was made, but we always also make sure to just have the date because it's kind of a longer thing. We have more years, but normally we do the specific date that the event was on to kind of show what we do. We've also started tracking our hours, which is currently not updated, but one of the things that you want to do because it just shows like how much time that you put in your outreach is kind of track how many hours each event is. We always kind of make sure to start by describing what we're doing, seeing what. So for this, we are ambassadors for First Like a Girl. If you want to learn more about that, go to their website. Also, if you're interested in handing out buttons, we also have stickers. So if you want any of those too, just let us know. But so if you're interested in being ambassador to First Like a Girl, so we kind of described that, showed us what we've been able to do, and also what we learned, as I said earlier. It's the same format. So here we are able to visit a company. We have kind of the date, and we talked kind of about what we did, and then also again what we learned, and we make sure to include as many pictures as possible because the visuals is really what makes your notebook stand out, especially for outreach because it is a lot of words, but you want to have, I know we like also putting some physical evidence. So if we're handing out pamphlets, we put the pamphlet into the notebook. If we have pictures of our business cards because we want to show all of our marketing materials and how we outreach through different materials and stuff like that. So we always make sure to have like examples of physical materials in our notebooks, whether it is the physical material itself or pictures of it. Pictures are just really important in general, as I said earlier. And yeah. So if you want to keep in touch, kind of going a bit more on outreach, have a team email, and as I said, Instagram, Twitter, those are 2 most active. We also have a YouTube We have a Facebook, but we don't really use it. Not gonna lie, no one on our team knows how to use Facebook anymore. But we do have a Facebook, and we also have a Reddit, a Discord, kind of to keep active within the first community, because I know there's a lot of FTC stuff. If you're not on FTC Reddit or FTC Discord, I highly recommend just Google FTC Reddit, and it's really easy. I know Reddit seems overwhelming sometimes, but it's really chill, kind of. There are a lot of memes, but that's a good thing, honestly. But if you want to keep in touch with us, so you can obviously email us at team7593@gmail.com. And of course, you can DM us on Instagram at ndbtigerbots or Twitter at ndbtigerbots. So now we'll be moving into the Q&A section. Fun fact, we're supposed to be at NorCal Regionals, but due to health concerns, we decided to not go. So I am able to do a Q&A session. So does anyone have any questions?
Thank you again, Team 7593, the Tiger Bots, for a great presentation on outreach. If anyone has any questions for Team 7593, please post them in the live chat. You can also obviously contact them at any of these channels. We'll keep the live chat going for another 5 or so minutes, and then we'll conclude the conference. Thank you. So that concludes our conference for today. I would like to thank team 14278ZO, 11056 The Ybot, 7486 Suffern Robotics, 9794 Wizards.exe, 12528 NextGen, 12808 Revamped Robotics, and 7593 Tigerbots for providing these amazing presentations we've had today. And if you guys have any questions or comments you'd like to see about future presentations, feel free to let us know. And if you guys do have more questions, we are obviously open to answer them. And with that, I would like to conclude today's conference. And thank you